So good morning, everybody. People are pouring in. Welcome to our session on the PEL and polyfluorinated alkylated substances and related contaminated sites. So a new and additional topic to the chlorinated pollutants. Thank you to the organizer for supporting us with this session. And this session was also given free for authorities in Europe and in Africa and Asia, which will listen to this very important topic. I will chair the session and give the first presentation, and I hand over to my co-chair, Guido.
Thank you, Roland. Yes, I'm Guido van der Golet from TAU. I'm stepping in for Dietmar Müller Grabherr, who's unfortunately not able to come. So I'm supporting Roland today.
Yes, but my co-chair, Dietmar Müller Grabherr, will be online and give a presentation in the second part of the session. So, yes, I will tell a bit my story on PFAS, contaminated sites, a personal journey, and some lessons learned. I'm working since more than 30 years on persistent organic pollutants, made my PhD thesis on fluorinated dioxins, and then in 2006 I got involved in a big PFAS contaminated sites, contaminating drinking water in North Rhine-Westphalia in Germany from agricultural sites. So that will be the first part of the presentation. Then some experience on remediation costs, PFAS contamination from PFAS production sites we presented in 2010. Then I have a few slides on the global perspective on PFAS contaminated sites, because today several hundred millions of people are above drinking water limits of Denmark and cross the planetary boundary. A few slides on liability of PFAS contamination and what happened at the moment in the United States. But at the end, I also would like to give a few solutions. One is that we are addressing PFAS on international level by conventions, and also we have a science statement and the European Union approach to regulate PFAS as a group. So in 2006, I chaired the first contaminated site session, and at that time, at the dioxin conference series, and at that time I invited John Fagan with his HCH cases. We had fluoralkali, and on my way back to the airport, a person from an analytical institute came to me and said, "Roland, there is something very big cooking because we have contamination of the Ruhr River and the Möhne River. Can you have a look at it?" So we did. And the main study here was done from the University of Bonn. You see, this is Germany and the Rhine River. And you see how the PFOA, that's 8-chain fluorinated acid, was increasing through Germany. And especially at this point, at the tributary rivers Lippe, Ruhr and Emscher, the levels of total PFAS was above 70 nanogram per liter, and of PFOA between 20 and 55 nanogram per liter. So then the researchers looked for the sources, and they found that here, this is the Rhine River, the Ruhr River was contaminated up to here the Möhne River. And what you have here, this is the Möhne Reservoir. This is one of the biggest drinking water reservoirs in Germany. And there they had more than 400 nanogram per liter of PFOA. So we had in this reservoir about 110 kilogram of total PFAS, including 88 kilogram of PFOA. The source was sludge, which was mismanaged from Belgium via the Netherlands, and a small German waste management company brought this sludge to Germany and gave it to farmers. So here we have one field, one area, where 10 hectares were contaminated with about 390 kilogram of PFOA and PFOS. And then the first discovery was that we have large challenges with PFAS contamination in drinking water. Most German drinking water works in 2006 did not eliminate, so the concentration in surface water and in drinking water was basically the same. So we had up to 700 nanogram of PFAS in drinking water here for some cities, including more than 100 nanogram up above 300 nanogram for big cities like Dortmund and Essen. So therefore, several drinking water works needed to be upgraded. The cost of around 5 drinking water works were more than 100 million euro. So the first lessons learned was upgrade of waterworks were needed for PFAS elimination, even for Germany. Large cost to filter drinking water, and the upgrade of these drinking water wells took years. And at that time, there was no drinking water limit. So therefore, the Drinking Water Commission of Germany need to set up drinking water limits. And you see here, they put 4 different limits: target value 100 nanogram per liter, PFOS, PFOA, health guiding values, less than 300 nanogram, precautionary action 500 nanogram, action value 5,000 nanogram. So that's the original presentation from me in 2007. I made a big question mark to that. Because when you calculate with the 500 nanogram per liter in a year, you would have finally milligram of PFOS in the blood after 1 year. So this could not be correct at that time. And over time now, these drinking water limits were reduced. So in 2016, the US EPA put health advisory for PFOS P4 of 70 nanogram per liter. And now in Denmark in 2021, they put the limit to 2 nanogram per liter for the sum of PFOS, P4, PFHX, and the nona acid. So this is based on the European Food Safety Authority, the tolerable weekly intake of 4.4 nanogram. So the lessons learned here is that the tolerable daily intake, the tolerable weekly intake, but also drinking water limits needed to be lowered over time, because we found that these chemicals have more sensitive endpoints for toxic effects. Yeah, and we are not sure if we are at the end of the tunnel. So here is just the calculation for the Danish drinking water limit, where when you have from the European Food Safety Authority the 4.4 nanogram, you can calculate for an adult that if you have 20% of your intake coming from water, that the drinking water limit should be about 3.8 nanogram. For a child, it should be around 1.2 nanogram. So let's say, therefore, Denmark choose this 2 nanogram per liter, yeah, which I normally use now to compare. What happened then? What happened was that there was a remediation of this larger contaminated area. So here they could achieve 90% reduction of PFOS and P4 flow into the Müller reservoir. But in 2008, still it was above 100 nanogram per liter, the Ruhr River and the Müller River, because they also found that there were a range of industrial emitters, plating industries and other industries. So another lessons learned was a systematic assessment of sources is needed, and industrial waste and releases were key at that time for the pollution. So here you see the values in one part of the Möhne River. So this is for PFOS and P4. So here, before the remediation, you see the levels of PFOS P4 was above 10,000 nanogram per liter in the river. After the remediation, it came down to below 100 nanogram per liter. So a lessons learned here for the remediation was that it is really challenging to remediate large areas like 10 hectares. So it was not possible, and it is still not possible, to really take out the soil. But the only thing what is possible is to do filtration of this area. And now, after 15 years, still we do the filtration, and it will have to continue. This is the concentration of PFOS, P4 in the water reservoir. So you see in the Möhne reservoir. So here we see also that it decreased over time, but it really started above 600 nanogram per liter. Yeah, one of the biggest drinking water reservoirs of Germany. And then you see, yes, it goes down, but over 10 years, still the levels are more than 10 times above the 2 nanogram per liter, yeah, in this reservoir and in the river. So very long time. This means with a few 100 kilograms of PFAS, entire areas and river system can be contaminated for years and decades. We need a very strong regulation and extended producer responsibility for PFAS. PFAS producers and users need to ensure end-of-life management and cannot transfer this to a small waste management company in Germany, because what happened? The German company, these were 8 people, so they went bankrupt. So therefore the cost of all this remediation and drinking water cleaning had to be paid by the public. And because of that, in this area, Düsseldorf is the capital from this area. So they made assessment in the city of Düsseldorf, in the groundwater. And what you see there is they found many PFAS contaminated sites in Düsseldorf city, but mainly from the use of firefighting foams. So there in 2008, yes, for Germany it was found firefighting foams at airports, different training areas, but also from chromium plating. And the further assessment, they found, okay, to monitor PFAS and to remediate PFAS is very expensive. So here, for the airport, just the cost of 3 wells, controlling the point sources, were about 2 million euro. Total remediation cost is estimated just for this airport to more than 100 million euro. And this is another part of the assessment, a fire from 2006. So here you see the assessment of the site was more than 1 million euro, and the remediation of this site with 42 cubic meter of firefighting foams was more than 10 million euro. And there is a cost estimate for another area in Germany, which we will hear in another presentation. It's 1,000 hectare of agricultural field. So here the estimate would be that the remediation cost 1 to 3 billion euro if you would remove the soil and clean up. But at the moment, even in Germany, we do not have a real solution for that. Lessons learned: remediation of PFAS from groundwater and soil is challenging and expensive. We do not have natural degradation of perfluorinated acids in soil or groundwater, so they are forever chemicals. And later in the session we will have today the launch of PFAS contaminated sites of whole Europe from a journalist consortium, which estimate that we have 17,000 sites contaminated with PFAS and 22,000 sites which are potentially contaminated. This presentation we will have in the second part of the session, but you can already look to the Guardian or the Le Monde. The message is out and the map is out. So in 2010, then I organized another session in the US at the Dioxin 2010, and there I invited the 2 biggest contaminated PFAS contaminated sites in America. And one is the Decatur, you know maybe from the Hollywood film from 2 years ago. And the other side is from the Ceenaeme in Twin Cities, St. Paul and Minneapolis. And at that time I invited Fardeen Oliaye. She was the principal investigator of that site. So here I just have one slide on lessons learned for the production sites. So PFAS production sites can have large PFAS contaminated footprint. Tens to hundreds of square kilometer contaminated groundwater. So here, this is the map of St. Paul and Minneapolis with the different landfills, yeah, and the water plume, what you have, yeah. Similar, we have something with Germany, 60 square kilometer around the factory, yeah. So the contamination is huge. Another lessons learned here: landfills from production sites can be large reservoirs of PFAS with long-term release potential and might need excavation, because PFAS are completely persistent, they do not degrade, and they are water soluble. So therefore landfills will leach over years, decades, centuries, 1,000 years. And liability of PFAS producers and users for the cost of environmental and drinking water pollution and for human contamination is needed. So here for Minnesota, there is a settlement between the government and the company is providing $850 million to cope with the legacy. And the disposal is not only a problem at the production sites, but also at the use sites of PFAS. There is one case of a shoe factory, Wolverine, hush puppies, yeah? So they used PFAS and they put it to landfills. So today, the area around this landfill is completely contaminated, including the drinking water. Then we have this PFAS on many products like carpets, textiles, fast food paper. And they have gone into landfills over the last 50 years use. And the problem is that these, the way how the PFAS were applied to carpets and to textiles and to paper takes between 30 to 100 years half-life time. This means these landfills will also leach for decades and possibly for centuries. So therefore, lessons learned. Landfills where PFAS waste has been disposed are long-term reservoirs, releasing PFAS for decades and likely centuries. And therefore, in 2010, we wrote that review article, yeah, where we already highlighted that this is an upcoming problem 10 years ago. And then the US EPA did a really great study. They analyzed 36,000 water samples, groundwater samples, drinking water samples in the United States. And at that time, they estimated with the 70 nanogram per liter that 6 million Americans were above the drinking water limit at that time of the health guiding value of the US EPA. But then afterwards it was found, oh, this is still 10 to 100 times too high, the 70 nanogram per liter, right? So therefore now the US EPA has even lowered the health advisory for PFOA to 0.004 nanogram per liter. With this limit, everybody in this room is above, I can promise you, all drinking water. But I take, therefore, the Denmark, which is based on the European assessment. When we take this 2 nanogram per liter limit for the 4 PFAS, and we take it for the US, you see that around 200 million Americans are above 1 to 2 nanogram per liter of PFAS PFOA. Yeah, 18 to 80 million are above 10 nanogram per liter. So lessons learned, large amount of people are affected by PFAS contamination in drinking water. With a friend at Tsinghua University in 2021, we did the same assessment for China, for all China. So we put all data which were available on drinking water, 520, together. So this was reflecting about the drinking water for 450 million citizens of China. And we found at that time we used the 20 nanogram per liter because in 2021 that was the lowest limit. Yeah, Denmark was not yet. So for 20 nanogram per liter, about 100 million citizens in China were above the 20 nanogram. If we go to the 2 nanogram, it will be several 100 million people in China which are above the Danish drinking water reservoir. And here, especially affected are those in the east and southwest region of China with organofluorine production and fluoropolymer production. Yeah? So also these industries have large releases and are impacting the rivers and the groundwater. And friends of mine did a publication about PFAS pollution cross planetary boundaries. So the planetary boundaries are the safe operating space of humanity. So here, the 4 PFAS, it is concluded that the global spread of these 4 PFASs has led to the exceedance of planetary boundaries for PFAS pollution because, first, the level of PFOA and PFAS in rainwater is often much higher than this very low limit which the US EPA is proposing now. This means all rain in the world is above this US health advisory. And some of the rainwater is also above the limit of the Danish drinking water regulation. Then many of this rainwater is above the European Union surface water standard, environmental quality standard of 0.65, and the atmospheric deposition also leads to contamination of many soils, and unfortunately from the soil it is partly going into the crops. So big challenge. So therefore In America at the moment there is a big activity about compensation by the industry and extended producer responsibility. We have more than 6,000 lawsuits over the last 10 years and the claim value is up to $30 billion US. So that's from Bloomberg Law article. I have given you here the link. And Robert Billett, so that's the attorney from this film Dark Waters, which came in cinema 2 years ago. He aims to sue major PFAS producers and former producers on behalf of millions of Americans which have PFAS in their blood. So it's very interesting to follow that. And we have the state of Michigan. So the state of Michigan also is now addressing 17 defendants knowingly designing, marketing, developing, distributing, selling, manufacturing, releasing, supplying, transporting, arranging PFAS, and is looking if they can get compensated for the costs which Michigan has with fighting the PFAS pollution. We have, and this is now part of the solution, we have PFAS now in the Stockholm Convention, PFAS since 2009, PFOA since 2019, and PFAS since 2022. So therefore, consequently, these compound groups are addressed and phased out globally. So we have made recommendation at that time that countries, all countries in the world, should look where PFAS have been produced, where PFAS have been used, and how they have been disposed. So this is a thing which is ongoing. And we have also from the Stockholm Convention draft guidelines for BAD-BEP. And this will be the last presentation of our session. The FAO is working on global soil contamination, including PFAS, and they will present the last presentation of our session. So in 2015, because we saw this big problem coming, a group of scientists, we have published the Madrid Statement on PFAS, which documents the scientific consensus regarding the persistence and potential harm. We have laid a roadmap and we have made recommendation for policymakers, industry and science. And the whole thing was published together with a dialogue with the organofluorine industry. Yeah, so it's important here that we have a science and industry dialogue. So I only show here our recommendation for governments and policymakers: enact legislation to require only essential uses of PFAS and enforce labeling to indicate the uses in the products. And what we see, Europe 2020, the European Commission in its chemical strategy for sustainability towards a toxic-free environment suggests to address PFAS as a group with the following action: phasing out the use of PFAS in the European Union unless their use is essential. Yeah, so similar what we proposed 8 years ago. And in February 2023, ECHA published a detail of a proposal to restrict of around 10,000 PFASs. So here I have also given you the website, so you see much is happening. And for my co-chair, that's the last slide. Yeah, thank you for your attention. And the issue is really huge, and I hope I have given you a first overview on that. I think we have time for one question, huh? And
Yes, I think if there's any questions, either from the audience here or online.
And if not, we continue with the next presenter and do questions at the end. Yeah? Okay.
Okay, let's continue.
Let's continue. So our second presenter is Dr. Joerg Frauenstein from the German Environment Agency, and he will inform us about PFAS in soil and groundwater, progress and comprehensive challenges in Germany. Please, Joerg, the floor is yours.
Good morning to everybody. It's a pleasure, and I feel really honored to be part of this 14th International forum in Zaragoza. I hope the slides are visible and my sound as well. So I start talking because a lot of slides on available. So what we did, and this is also a good continuation to Roland's presentation, we on the German level as well on the European level in different networks, we went along this DPSIR approach, where we looked some different elements, the drivers, the pressures, state, impact, and response in order to develop some kind of approaches and regulation, how we can solve the problem with PFAS for the future. I think this is an important element of our environmental policy, and therefore, let me explain how we try to do it. If you look a bit more in detail, you will see on this slide the different sources. On the left-hand side, you see the relevant pathways which are related to PFAS in a focus, and as well the receptors. And you see we have so many different possibilities how we can be contaminated by PFAS, their elements or their products or some residues. And therefore, this kind of figure is important to get the complete figure. There are many direct sources for sure, but there are also some on the hidden agenda. So look a bit more in detail. Really often PFAS are identified together with firefighting foams, but the whole screen is much wider. We have PFAS in textile industry as well as in the chemical industry. This will be used for the production of semiconductors. We have in many papers and photography these kind of coverage of the papers which gives the brightness comes from PFAS. And we have PFAS also in hydraulic fluids and paints and varnishes. And you see as well the impact to the different environmental media. A lot of PFAS are going via earth, waste, the mass streams of the circular economy, soil, excavation, and ground and wastewater. If we look at more from the driver's side, of course, on first of all, the industry, which is still increasing the complexity and chemical design of these substances. And so the registration is also an issue because the environmental impact assessment is hardly to fulfill. Of course, there's also a driver side coming from the research, because the fragmented understanding of fate and behavior, especially for mixed toxic effects of PFAS, the society is also faced because of the lack of precautionary principles in our environmental policy. The problem is also the awareness. Really often we see a huge delay from the realization. There might be an effect to the practical behavior. Maybe an example could be the coffee mugs, which will daily used by people around the world. And of course, the administration is faced with, because the limited ability to analyze PFAS. I guess my colleague, Mr. Lange, will present in the next presentation about this. So there are so many things, and then overall we have bad news and headings from the media. I guess also the presentation of the journalist network today will get another input as a driver that the society have to do some work and increase the effort for PFAS. Okay, what are the bottlenecks? The bottlenecks are more or less extracted from an international PFAS conference we held under the German presidency in Berlin in 2020. During the Corona time, we had online more than 700 people there, and also some guys are presenting today, especially Xenia helped us in this presentation. What are important? There is no pre-market safety check obligation for new substances. We have difficulties to identify in the society our essential uses. You know that the reduce of PFAS also in relation to essential use might be a trigger. We have a very time-consuming regulatory process, and we have to avoid regrettable substitutions. So these are some of these issues we have. On the right-hand side, you see that the regulation of PFAS from the production state in 1950 to 2020, it's a long way and we are not really finished yet. Going to the state and dimension of PFAS, for Germany and Europe, I can also refer to some hotspots Roland mentioned in his presentation. And we have numbers from Germany based from 2019. And we have heard today about the update of 2022. We have 1,771 sites under suspicion. Among this, 684 are under investigation and assessment. And so far we have 76 in remediation and 11 cleaned. But we have to state that this number is certainly underestimated. And a review of already registered contaminated sites with regard to PFAS is not yet completed. This is also an issue we are faced with. We assessed so many suspected sites in the past, but often without any focus on PFAS. And this we have to reinvent now. If you look on the presentations, or if you look on the regulation, of course, we have some substance regulated in the CLP directive. There are also a lot of substances of a very high concern nominated and defined, and we have some restrictions within the REACH process. We expect within this year some more restriction for elements, but you see we are talking about a couple of substances and mixtures, but we have to realize that the group of PFAS is, depending on your interpretation and definition, concludes more than 10,000 of different substances. So that we see, and Roland also mentioned it, that only if we can regulate the total group, we can get some success. And therefore, 5 European member states launched a total restriction proposal. This is currently under consideration, and within the group of European countries are the Netherlands, Denmark, Sweden, Norway, and Germany. So going further, the EFSA was also mentioned often by Roland. We see that the values the EFSA launched to guarantee the food safety will become more stringent, and with each step that values will be more strict. We have a a problem in our regulation. And this is one of the issues. On one hand side, we have to realize that the risks for the people is increasing, but we have also to see the overall system of the source, pathway, and receptor. Therefore, sometimes we need a kind of translation between these EFSA values and the values we use for our remediation. I will go more in detail a bit later. Yeah. Other regulations to PFAS, we have, of course, the Water Framework Directive. There, PFAS is one of the priority substances, and we have created the environmental quality standards, which serves a benchmark concentration for harmful effects to wildlife and humans. And we have the EQS for PFAS for 9.1 microgram per kilogram in fish. Here you see also a presentation or the publication of this source as well. Going to responses. As mentioned, we see PFAS all around in the society, all around in the environment. We have indications of PFAS findings in the polar bears, and therefore we have to act very soon and very strict. So therefore, PFAS is also part of the European Green Deal. We see some interfaces, and if you look on the total, in this total element, we have especially the zero pollution as an ambition in the EU, which will catch this problem. And of course, we have interfaces to some other regulations which are in progress or just finished now. Well, let me go one back. You see also the different interfaces to soil waste, industry emission, and research, and all these elements are more or less a level playing field in the European politics at the moment. The human health assessment in Germany, we have a human biomonitoring panel to observe the human epidemiological and animal studies, which an HBM panel, and they decided the HBM value in blood plasma, which is defined for 2 nanograms per milliliter for P4 and 5 nanograms per milliliter for PFOS. Here you see also the link to the presentation. If you are interested, feel free to look into. There's also a development in the EU Drinking Water Directive from 2020, which allows a total PFAS concentration of 0.5 milligrams per liter. And as if you look in a total PFAS of 20 substances, then for one substance, 0.1 is allowed. There is also the development of a CEN TC230 in preparation, and by the start of 2024, the European Commission shall establish technical guidelines regarding methods of analytical and monitoring new PFAS parameters, detection limits, parametric values, and frequency of samples. By 2026, the member states shall ensure the compliance with these values. There are some more regulation for PFAS implementable. One effect is, of course, the water supply. Roland talked about some triggers. Here also we have some demands from the EFSA, and they realize that more of 20% of analytical drinking water do not meet the demands. Analytical feasibility is also an issue. We see that the EU Drinking Water Directive might be feasible in analytical terms, but if we look on the concentrations the EFSA is demanding at the moment, we do not have stable and lab routines. Another issue is our water treatment systems in the European Union. Most of them are not able to filter out these PFAS, and we know that the false remediation cascade in our water treatment will increase the cost for the water supply dramatically. What we did in Germany, we put together all these values we have in a harmonized guidance for Germany. You know, Germany is a federal system, and the different federal states have somehow different regulations. With these guidance, there is a document available which all member states adapted, and these will include analytical recommendations, the use of significant thresholds for assessing groundwater and soil eluates, the guidance how to prepare soil eluates, a guidance to analyze PFAS. And an important issue, and this was also part of the presentation of Roland, we have some diffuse pollution in agricultural land, and therefore a pre-harvest monitoring is an issue. It is an approach which could help to give the farmers also security that they can sell the fruits and the vegetables from their farms. Because we are able to predict the PFAS concentration in these agricultural products. And of course, we have guidance for the handling of soil material containing PFAS. This is part of a new ordinance, and we included also some case studies. If you go direct into the tables, we have values for groundwater and soil eluate. You see the different regulated PFAS substances here in the values, which are indicated in micrograms per liter. And as mentioned before, of course, our society is also dominated by a lot of construction work, and many of the excavated soil is also containing PFAS. And what we have in mind is that PFAS contaminated should not be landfilled or backfilled at places with no or lower PFAS pollution. This is also, let's say, a main principle which is implemented in our in this table for categorizing backfill materials. Here you see also that we have different recovery classes for, let's say, for different characteristics of containment, and of course they have to be lower if there is no limitation and no security implementation. What are upcoming initiatives? If you remember these HBM1, we are now talking in Germany about the HBM2 implementation in order to indicate necessary and proportionate measures for related pathways and protected goods. We try to increase and develop the pre-harvest monitoring further up to an ordinance level, and we want to develop also the guidance for PFAS in the next years. If you look on the applicable remediation techniques, of course, at the moment, dig and dump and pump and treat are still the most frequent used technologies. We know that they are often enormous, cost intensive, and really often it is not proportionate from the technical point of view to carry out these measures. Therefore, of course, there is a huge development in order to develop new innovative techniques which are arising, but we often miss, or they're actually often an independent technology and cost efficiency evaluation is missing. What we see in Germany is that soil washing is becoming attractive, especially if we have a soil quality with a lot of sand and let's say pieces of soil. It is not so effective for soil or for binding elements in soil. The idea is to separate the sand out of the total excavated material. This can be cleaned very easily in the soil washing equipment, and we can reduce the fraction which have to be incinerated on a high temperature level in order to destroy the PFAS. However, PFAS remediation itself is just one criteria within the overall assessment of a management approach. In parallel, we have to look for options for large-scale PFAS pollution. Here we are talking about immobilization. Maybe a lot of you have heard about different products on the market. However, we have to prove and check the long-term effectiveness of these materials. And another burning issue is the future use of these soils, which contains immobilized PFAS. This is also an issue which is present all over Europe. And these hurdles are also relevant for excavated soils. And last but not least, we have to think, or at the moment we see a best option for many measures that we remediate at the point of use, to see preferential options, especially for drinking water, irrigation, and agricultural land. Legal regulations for large-scale contamination. Of course, there are some options possible. I have to hurry up a little bit. The remediation plan as a supporting tool for the administration. Of course, the designation of areas, which might be an option. We used it for heavy metals in Germany in mining regions, and we have special management rules for these areas. We are thinking if we can do it also for artificial substances like PFAS, but of course there is a higher interest in security in this regard. And of course, an action plan is a steering tool for the municipalities, could be a way forward. If we look what is important for the future, for the manufacturer, the chemical design, which should be more safe, more sustainable, and with non-toxic material cycles, the avoidance of forever chemicals should be a target for the future, and also which is also in line with the non-toxic ambition of the European community. For the society, we have to define the essential uses. For the researchers, only to highlight one, is to provide a toolbox for better assessment of fate and behavior, especially for mixed toxicity, for other chemicals, and for the administration and broader monitoring and their impact on protected goods and the implementation of avoidance, mitigation, and remediation. However, the story of PFAS shows that we often are faced with unbeknownst pollutants, and we have to make a kind of a strategy, how we do it, how we handle these unbeknownst pollutants in future. Here, the triangle of known knowns and unknown unknowns is a very specific one. What we should do, I guess, first is accelerating information flows, as we do it with these international forum to change information and to check and organize an output, a better output. Lessons learned and take-home messages. We see that critical chemicals need to be identified before they are widely used and spread it into the environment. We need a periodic review and update of safety data sheets to improve and facilitate environmental assessments. We have to transfer quickly applied research findings. And last but not least, we have to accompany different or accompanying measures. Here, networks can have a big input. Dietmar Müller, Grabherr, will report in the afternoon session about the activities of a PFAS group within the common forum. And we see some other issues here. So the most important is PFAS could be somehow a blueprint for emerging pollutants in future. We learned a lot from the PFAS case, and we will see, and I'm quite sure, some other critical pollutants in future. And if we keep the messages from the process with PFAS and some other critical chemicals, we can do in future a much better job. So thank you for presentation. I will not forget to acknowledge my co-author, Annegret Biegel-Engler. Thanks for listening, and any question, feel free. Thank you.
Thank you. Thank you, Dr. Frauenstein. I think there is room for one question. Yes.
Thanks. You showed a map of hotspots in Germany,
yeah.
and it seems that they're associated with the specific point sources. And I would like to know if that those hotspots were defined based on health-based environmental quality standards for the protection of soil and groundwater, or they were defined as compared to background levels, and what can be expected as background levels around those spots? Thanks.
Okay, thank you for your interesting question. The hotspots I showed in my map are often a result of a first suspicion which was investigated. Maybe I forgot to explain what we do currently in Germany is we try to develop a background level value at the moment in a research in our Federal Environment Agency. At the moment, we have some limited values as shown in my presentation, but we will make the system better. At the moment, what we are doing, or what I did in the map, we received the data from our federal states, and the hotspots I showed in my map are concentrating on sites which are still in assessment and remediation. I hope this gives an answer to your question.
Okay, thank you very much. I need to go to the next speaker, which is Dr. Frank Thomas Lange from the German Water Center in Karlsruhe. And the title of his presentation is Investigative Soil and Water Analysis at an Outstanding Large-Scale Contaminated Site. How Novel Approaches Can Help to Solve the PFAS Puzzle. The floor is yours, Dr. Lange.
Thank you very much. One moment, please. Can you hear me good?
1 second, you're not on the screen yet. Yeah, you're on the screen, and I think you can start. I don't. Yes,
okay.
You are on the screen. Yes, go ahead.
Okay. Thank you very much for the introduction, and thank the organizers for inviting me to give this presentation today. And welcome to everybody this morning to this presentation on this very large-scale contaminated site, the so-called Rastatt site in southwest Germany. And I want to show you how the analytical chemists bring some novel approaches and can help to solve this absolute PFAS puzzle. So worldwide, there are lots of sites where soil and groundwater are contaminated by PFAS. Most often, this contamination stems from the application of fluorosurfactants in firefighting foams. We heard about this in the last two presentations also. In southwest Germany, about a decade ago, we detected the so-called Rastatt case, where PFAS contaminated paper fiber biosolids from the production of grease-proof contact materials have been mixed with compost. And the soil on agricultural fields was amended on a very large scale. That means with thousands of tons of contaminated biosolids over several years. The question was, what PFAS, that means which active ingredients are present and at which levels? This was not known to us at the beginning, and what we do not know, we cannot analyze. But information on the total PFAS burden was urgently needed, that time and also today, because these active ingredients are so-called precursors. Precursor means that they will degrade over time, that means break down in the soil, and finally give persistent and mobile perfluoroalkyl acids, so-called PFAS, which, for example, can contaminate drinking water sources, like shown on the right-hand side of this figure. To give you an idea of this contaminated site, you see here a map. It's located close to the border between Germany and France, on the east side of the border. And the data by end of 2022 were that about 10,000 groundwater samples have been analyzed and more than 5,000 soil samples have been analyzed. The extension is approximately 10 times 20 kilometers, and there are numerous individual sites. About 3,000 hectares have been investigated so far, and more than a third, 1,100 hectares, have been defined as contaminated. The distribution is random among the sites, and there are numerous individual PFAS detected. There are also unknown precursors, and that's the biggest problem we face as analytical chemists in this region. You see here also the blue areas, which are the catchment areas of different waterworks, and the red labels here are contaminated sites, and the green one are not contaminated sites. They lie close together, one by one. And you see that the catchment area of the waterworks are also included here in the plumes of these contaminated sites. So the analytical challenge was measuring PFAS total. We need to know the total PFAS burden in order to have a measure how much PFAS can elute on long term from this site. And the driver for our analytical development is the sheer number of the PFAS chemicals which are on the market. 5,000 or more PFAS are expected to be in the environment and on the market, but only estimated less than 3% are measurable by quantitative target analysis. And that's due to basically 2 points. The first is the missing knowledge on chemical structures, because many of the active ingredients are confidential information of companies. The second point is missing reference compounds. For most of these chemicals, no reference compounds are available, and these are needed to calibrate our chemical analysis to do quantitative analysis. So these 2 points, they urge that there are missing analytical protocols we still have to develop. So we decided to go the following strategy. We wanted to extend, first of all, the target list we had already. And the second point of the strategy was to add different analytical methods with the so-called sum parameters or surrogate parameters. If you go onto the field already today, or still today, you find such white lumps of fibers on the fields on the topsoil. And these fibers, they include grease-proofing agents for food contact materials. But it was not known to us at the beginning of our analytical work which kind of grease-proofing agents there was on. But we had to look at the literature, and last but not least, also in the publications of Xenia, who is presenting this afternoon. And we found that 2 types of legacy grease-proofing agents are likely to occur there. This could be, on the one hand, the PAPs, the so-called PAPs, which are phosphate esters of telomere alcohols. This is given in red here. These are the typical products of the DuPont chemistry in former times. And the second group is a group of so-called DPAP. DPAP is a typical product of the 3M chemistry. And these are not pure chemicals, but for example, the PAP, they constitute of a number of homologues with different chain lengths on left and right of this phosphoric acid center here. That means you can have chain length 6 and 6, or 8 and 8, or 6, 8, 8, 10, 8, 4, and everything you can imagine. That means we have technical mixtures of many individual chemicals, which makes it very difficult to analyze them. But at the time we expanded our target list, we had on the market already some reference compounds for these homologues of the PAP. And also there was a reference compound for this D-SUM-PAP shown here. If these chemicals break down, for example, the PAP shown here, it's very complicated, don't be confused. We have the original chemical here on the top, and through many pathways, finally in the end, they end up after degradation with a mixture of so-called perfluorocarboxylic acids. These are absolute stable, persistent chemicals, which are very good water soluble and also very mobile. And these are the chemicals typically which reach the sources of the drinking water companies, for example. Most of the other chemicals here are not found. These are intermediates with a short half-life, obviously. And even if you find one or the other ones, it's always in small concentrations. Similar is the degradation of the D-SUM-PAP. D-SUM-PAP is also a very complicated molecule. It breaks down to its major building block from which it's constructed, the ethanol, that is this alcohol. And this alcohol breaks further down to give finally PFOS, which is well known in the PFAS society. So in contrast to the PAPs, the degradation products of the D-SUM-PAP, they are more stable. And most of them can be found in the soil and also in the groundwater in this region. You see here on the right an example of intermediates found in a soil in this Rastatt area. And you see that sometimes such intermediates also exceed the concentration of the final product PFAS. So we included all these in our target analysis and were able to quantify now more chemicals than before. And then we combined it together with another analytical approach. That means measuring so-called sum parameters or surrogate parameters. And there are different types of parameters. Today I want to present results from 3 measurements. The first is the so-called EOF, the extractable organically bound fluorine. The second is the so-called top assay, the total oxidizable top assay. And the third is the NMR technique. This is very strange in environmental chemistry, but the concentrations here in this area are in some of the fields so high that we were able to measure even with NMR technique. So the first 2 techniques here, the EOF and the top assay, they are destructive techniques. That means the original chemical, shown here as a fluorosurfactant, is either combusted totally in the EOF method to give finally fluoride from the HF, which is formed in the combustion. And we detect this fluoride, and this is a measure for the extracted, from a sample extracted organic fluorine. It's obvious that we lose totally the information about the molecule and only have a measure how much fluorine stems from such kind of chemicals. On the other hand, a more specific method is the total oxidizable precursor, because it destructs the original molecule, but on the other hand, it's not mineralized totally, but the products are these carboxylic acids, these fluorinated carboxylic acids, and these can be easily, today at least, can be easily detected by LCMS, routine analysis. And in this way, we make visible unknown precursors by oxidizing them to known degradation products, which we can quantify. The NMR technique, in contrast to both of these techniques here, is a direct method. That means we do not have to extract the sample before, for example, by methanol, but just measure the sample as it is, a dried soil sample directly measured by this method. Please keep this in mind. This is very important information that all the other methods here on the top use methanolic extracts and therefore only give always a part of the reality. As you can see here, this is a flow chart for the soil, for the EOF determination in soil. And what you can see is it consists of 4 steps, and each step can discriminate one or the other chemical. For example, if the chemical is not extractable from soil with this solvent, then it remains still in the soil. If it cannot be adsorbed because it's too polar, it's not adsorbed on the weak anion exchanger. And we absolutely need this fluoride removal in the extract to be sure not to analyze inorganic fluoride, which is in large excess in these samples, but to measure only organic fluoride. And finally, if the sample sticks too much to the adsorber, we cannot elute it. That means each of these steps can discriminate some of the chemicals. So what we see is a part of the reality, an extractable part and eludable part of the extract we produced originally. And finally, in the extract by combustion ion chromatography, the fluoride is measured. This is shown in the next slide. I hope it will come. Yes. The methanolic extracts are combusted in an oven, and the combustion gases are absorbed in water, and hereby the produced hydrofluoride dissociates to give fluoride, and fluoride is quantitatively determined by ion chromatography. And now, if we bring together all information, that means we make a mass balance of organofluorine. And this is a mass balance between the measured extractable fluorine. This is the total gray bar here. And we add up all the fluorine contributions of single compounds which we were able to measure. For example, the black one here from the PUBs, the green one from the SUMPUB, and the others are the degradation products. And if we sum up all measurable targets, we find that there is still a gap to the EOF value, and this gap is the organofluorine which stems from unknown precursors. That means by doing such a comparison, we can make visible the content of extractable unknown precursors. You can here see, for example, the gap is smaller here. In fibers, we also investigated. Here we can explain a lot of organofluorine by the target PUBs and DPUBs and their degradation products. The second approach for digestion sample to make visible unknown precursors is a so-called top assay. And this is an oxidative digestion based on hydroxyl radical oxidation. And by this way, the precursors shown here in these 3 lines, precursors are oxidized by OH radicals to give the fluorinated carboxylic acids. And as I said before, these can very easily be analyzed. If we have sulfonamide precursors like 3M products, we get only one chain length basically. If we have fluorotelomere-based precursors like the DuPont chemistry or others, they give a suite of different chain length carboxylic acids. It depends a little bit which endpoints of carboxylic acid you analyze, especially if you start with short chain precursors, you can end up with very or ultra short chain PFCAs, and they are mostly not included in routine analysis. So if you don't analyze C2, the trifluoroacetic acid, and C3, you will always miss a bit in the mass balance. So what can we do? This is a little bit statistics of top assay applied to soil extracts, methanolic extracts, and on the other hand, to soil leachates, aqueous leachates. And as you can clearly see on the ordinate here, there is a factor given. This is a factor of the sum of all measured of these oxidation products post top assay, that means after top assay, compared to before. And that means if the factor is 1, there is no production from unknown precursors. If it's larger than 1, there have been unknown precursors in the sample extract or in the sample leachate. And as you can see in the leachate, the factor is very close to 1. The median is 1.2. That means on average, only 20% of PFCA are produced from yet unknown precursors. But in the methanol extract, we have an average of about fourfold increase in the soil extract, and in individual samples it can go up to 20-fold or 25-fold increase from unknown precursors. I will skip the next 2 slides. They show more or less the same. And sorry, there's some background. Can somebody close the mic?
Yes, this is Guido from the 2 minutes.
That's a bit confusing. Okay, thank you. This shows a comparison of the methods here. This is a depth profile in soil in this Rastatt area. And on top, you see the first 10 centimeters and then going down in depth. And we compared the different methods, their outcomes based on an organofluorine balance. And you clearly see that EOF, the sum parameter EOF, and also the PFAS after top assay, the red bar, blue and red bars, they show high concentrations of precursors in the top, let's say 30 to 40 centimeters. And that's the topsoil, the bluff horizon, where most of the precursors stuck to. If you would have measured only the native ones, the native PFAS by routine analysis, these are the green bars, we would have overlooked most of the organofluorine which stems from precursors. And you can also see in deeper layers, for example, in the third layer here, the concentrations of all, from all three methods gives similar results. And even deeper, the EOF is too insensitive to measure the values at all. And the other two, the top assay, that means post-oxidation and before oxidation, give basically the same value. And that means there are nearly no precursors in deep layers, and 80–90% of the precursors in the top 30 to 40 centimeters. I have a problem that it's not going forward. Now, okay, sorry. So, a similar comparison we did with the sum parameter and the and the PFAS analysis in some crops which are grown on contaminated soil. This was done in a following project. And what we see here clearly is that the blue bars, which represent the EOF, are very small compared to all others. And the reason is that in these plants, in these crops, mostly very short chain to medium short chain PFCAs are accumulated. That means trifluoroacetic acid, you see values on the right here, has a large part in these crops, but also other short chain PFCA. And because the EOF discriminates this short chain PFCA, we cannot see it when we apply EOF. That means EOF application to crops does not make sense because it discriminates the relevant compounds. On the other hand, we see that the top assay, which is the red bars here, the top assay is in most cases a little bit smaller than what we measure by target analysis. And this says two things. First of all, we see that obviously precursors do not play a role in the transfer between soil to plant of PFAS. And we also see that the top assay results is a little bit smaller, and that's because with each chain shortening during the oxidation reaction, you have 2 fluorines lost with each carbon lost in the fluorinated chain. And this means they must be a little bit smaller if there are no precursors than the native. On the other hand, the native, that means the not oxidized sample, the green bars here, they show that target analysis is fully sufficient for crops. And that's a good news for pre-harvest monitoring, for example.
Can you come to the conclusions?
Yes. One moment. And now I just want to show you this, and then I stop the presentation. We have thought that this would be the truth, but when we applied the NMR technique, we saw that we have, this is a direct technique without extraction. We have confirmed that we have CF3 and CF3 two groups in our chemicals. And when we quantified this by standard addition, we finally found that a large fraction, that means larger than 80% of non-extractable residues is on the field. And that will be the task of the future. If I would have a little bit more time, I would have shown you an approach which could help to do this, but due to the time limits, I will stop here. And finally, I will thank all the organizations which are involved. and the people involved in all these projects and in the financial funding, and especially my colleagues here at TZW. And I thank you for your attention.
Yes. Thank you, Frank Thomas, for this very detailed analytical presentation. And you see, let's say, the complexity also when it comes then to the real results. Yeah, here he is from the authority and he needs to do the measurements that finally authority can make the appropriate measures. We will have a discussion at the end of the second part of the PFAS session, Frank Thomas. So here I would like to move to the next presentation, yeah, that we keep the time for this first session. And the next presentation comes from Dr. Schroeters from the University of Antwerp in Belgium. And her talk is about the Belgium 3M case from the health perspective.
So I thank the organizers for the opportunity to talk to you today on the recent PFAS scandal we had in Belgium. And I want to talk to you with respect from the health perspective. You know that the health effects of the PFAS are well established by now. So the health effects of the PFAS are well known. In the adults, we have the liver diseases, we have higher increases of cholesterol, we have also testicular cancer and kidney cancer, while in the developing organism, the reduced response to vaccines and lower birth weight are very well established endpoints. There are more endpoints as well, but they are not, the evidence is less clear for them. The main information comes from studies with PFOS and PFOA, while the other compounds are less studied. In fact, the setting of the limit values by the European Food Safety Agency in 2020 is based on the reduced response to vaccines observed in 1-year-old children. And this study has been used to develop a tolerable weekly intake value, which corresponds to a serum level of about 6.9 microgram per liter in pregnant women. And this can be also looked at as a human biomonitoring value, as a guidance value, above which health effects, adverse health effects cannot be excluded. This value is much, much lower. It's about 1,000 to 10,000 times lower than the previous EFSA limit value of 2008, which was based on liver damage in adults. So if we now go to the 3M site, I will try to, oh, well, that is something wrong. If I, yeah.
That's fine.
Really.
Yep.
Yeah, if we go now to the 3M site in the neighborhood of Antwerp, you see Antwerp is in the northern part of Belgium, in Flanders. It's close to the River Scheldt. It's about a city of 500,000 people. To the north of the Scheldt, we have the Netherlands. To the south, we have Flanders. And in the curve of the Scheldt, there is the 3M plant situated next to a nature area and also close to a city which is called, a community which is called Zwijndrecht. And the city of Antwerp is at the other side of the river. The fact is, in order to reduce the traffic pollution problem, the air pollution problem in Antwerp, about 2017, they decided to dig a tunnel under the River Scheldt, and they started the excavation works not so far from the 3M site. And that's where they discovered a high PFAS concentration, PFOS, it was PFOS in the topsoil. So if we look back at the 3M plant in Zwijndrecht area, so close to Antwerp, was built and is operating since 1971. In about 2002, the company voluntarily stopped the production of C8 compounds, so PFAS, and mainly PFAS they produce, but also some PFOA. But they continued the production of C4 and the short chain compounds in the Zwijndrecht area up to now. At that time, around the years 2000, we had little information. There was some elevated concentrations, slightly elevated concentrations of PFAS in some groundwater wells at the 3M site. A little bit later, some publications were found in the literature on high levels of PFAS in fish and songbirds that were catched in the area. This was well before the first EFSA TDI was set in 2008, and certainly long before in 2020, the new EFSA TDI was set. Now it's about that period, about a little bit before 2020, that this excavation works at the site started. And in some topsoils, this high PFAS concentration were discovered. This initiated some concerns in the area, and also some questions were raised in the parliament. There were more samplings and monitorings of this soil in the area. And indeed, if you see here, the levels that were found were very high. Next to the 3M site, up to 1,000 microgram per kilogram PFAS was discovered in some topsoils, while in the nature area, it went to about 100 microgram per kilogram, and in the Zwijndrecht area, this is the community, up to 20 microgram per kilogram. This is much higher than the data we had from other Flemish soils, which was about 0.78 microgram per kilogram dry matter. So what was the response of the local community? The residents, they were really concerned about their health. They asked also questions on whether we can still consume our locally produced food, and what is the value of our houses, of our residences, who will pay for that? And there were also some action groups which were organized. They sought in the first place support from scientific experts. They also organized some small monitoring studies to have some soil samples analyzed, and also some 9 serum samples from residents. They also were very active to look for media contacts, and they initiated some lawsuits. What was the response of the authorities? The authorities, when this discussion started, they nominated a commissioner, Karel Franken, who is from the same institute as I was working at that time. And his task was to build trust by a transparent communication. Therefore, he brought all the people together and made sure that the monitoring data and reports were fully available also on the website. There was also a mailbox where all the questions could be gathered and answered. And he delivered information to different stakeholders. The idea, well, the main aim was to bring really information to raise awareness for the problem, but also to avoid panic and avoid minimizing the problem. The second task was to build partnerships among the stakeholders. And the goal was to make an alliance to support the sanitation. And he made an alliance between the local authorities, between the company who did the construction works, nature organization, actions groups, and also the 3M company. And his third point was to bring the knowledge, the expertise, the scientific expertise together, to bring monitoring data together, to generate new knowledge in order to support policymakers. So the final aim was to come up with stronger regulation, and also with an expert hub to come to a long-term solution of this type of problems in the future. So the other thing the authorities established was, it was mainly the Agency on Health. to implement some no-regret measures. They made some recommendations to the residents, certainly the ones who are living close to the 3M site. And these recommendations were, for example, limit your consumption of homegrown vegetables, limit your consumption of eggs raised in the area, from the chicken raised in the area. Do not use the well water as drinking water, and also not to water your vegetables. Also, the indoor dust, try to reduce indoor dust by wet cleaning and avoid that your children play on fallow land. These were recommendations to the local residents. The other thing was that the parliament installed also an inquiry commission, and the ministers, they were seeking for the responsible people who was responsible for this type of problem. So the ministers had to come to the parliament, but also the managers of the 3M company and also several administrators and scientists had to testify. They also established an earth moving committee who had to deal with the excavation works. Could they still go on? Was it not a too high risk for the residents, or should there be some further adaptations before the excavation works could continue? The other thing was that a lot of monitoring data were needed, and this needed also some method development to measure not only the traditional perfluorinated compounds, but also the short chain compounds, the intermediates, like we heard before in the talk, precursors, alternatives. So there are a lot of activities were on method developing for different matrices, also for accreditation of these methods. Also, some research projects were initiated, meant to know more or to learn more about human exposure. For example, a human biomonitoring study was started, and I will come to that a little bit later. The aim was to see whether the no regret measures had to be refined, and to get also information on more PFAS compounds, on the internal concentrations in the people on the PFAS, on more than the traditional PFAS compounds. Also, the monitoring data were used to do some modeling, exposure modeling, in order to come up with risk-based limit values for soil and groundwater. With respect to health, also the cancer data of the cancer incidence data of the area were looked at and compared with those of the rest of Flanders. But Zwijndrecht is a rather small community, and the statistical power was not really very high enough to really make sound conclusions. In the future, a new biomonitoring study will start to look not only at exposure, so the internal dose of the pollutants, but also at the effects in 300 adolescents. And all the people in the vicinity within 5 kilometers of the 3M sites were recently, in January 23, invited to have their serum analyzed. And also, when this data will be collected, there will be some information also collected on the health of these participating individuals. So with respect to the PFAS, you all know there are a variety of exposure pathways for humans. We have PFAS present in a lot of consumer goods, furniture, packaging, paper, cosmetics, but also the industry releases PFAS in the environment, and if on the soil and with the water, vegetables and food is grown, that's an important additional source for human exposure. But it's very difficult to predict the real internal dose of humans, and that's why we prefer to take a serum sample to really learn what is the internal PFAS dose of the people, of the residents, and what entered their body. So a biomonitoring study has been initiated in 2021, and all the residents within 3 kilometers of the 3M sites were invited when they were above 12 years old. One participant per household could be involved. And in total, 800 participants were included in the study and their blood was sampled. They also answered some questions with respect to the family composition, also their health status, but also whether they have a garden or not, whether they consume their own vegetables, whether they consume their own eggs. We had information about the social economic status, about their occupation, some hobbies, and also their use of products. So what came out of this first biomonitoring study? Well, we have some data now on the levels of the perfluorinated compounds, of at least 10 perfluorinated compounds. Some of them we measured the linear and the branched compounds. Those people were living within 3 kilometers of the 3M site, and you see here the geometric means and the 90 percentiles of these group results at the left of this slide. We also, in combination with the questionnaire data, could see which factors influence the exposure. And for example, we could see that men have on average higher levels of PFAS than women. Older participants have higher levels than younger ones. Non-Belgians had lower ones than Belgians. Obese people on average had also lower values than non-obese people. But if you lived for example, more than 30 years in the study area, if you consumed your own eggs, if you always ate eggs from the area, if you use your well water, or if you lived very close to the site, those residents had higher levels than the ones who did not. So this became very clear from this study. And if we plot, here you see to the left, the results of the serum levels of the residents of the 3M area in yellow at the left side of the graph, compared with the graphs obtained from the general population in Flanders. These are PFAS values, medium values, and 90 percentiles. Then you see that the yellow bars are much, much higher than the ones from the average Flemish population. So we could conclude that the people living close to the 3M site had really, some of them had really high levels of, in this case, PFAS, but it was also true for example, PFHX in these residents. If we then compare these values of which we obtained with the health-based human biomonitoring guidance value, which corresponds to the EFSA TWI, then we have to compare it with 6.9 nanogram per milliliter serum. Then we could see that, for example, 70% of the Flemish teenagers of the general populations exceed these values, but at the 3M site, the majority of the residents really exceeded these health-based guidance values. This means that we cannot exclude that adverse health effects will appear. So what was now the consequence of this? The problem is that if so the major, an important source is food and also locally produced food. But if we look at the general food consumption in Belgium, then and the levels of the PFAS present there, then based on some modeling data, we have to conclude that already for the general population consuming food purchased in the normal shops, that this fills already up the EFSA TWI. This means that in principle, no additional source can be accepted. So this is difficult how to deal with this, of course. On the other hand, also, we have no food action limits for fruit and vegetables, only some for meat and eggs, but they are a little bit outdated because they are based on EFSA 2008. So what to do? Well, the action which was put forward was to try to limit the highest exposures and to further implement the no regret measures that were locally recommended measures. With respect to the soil, that is also a problem. The soil is contaminated in the area. You will hear more of it in the next talk. But this knowledge, this gained knowledge, resulted in a strengthening of the limits that are used for starting the remediation. And for example, for residential area, the limit due to this new knowledge was reduced for PFAS with a factor of 4, for PFOA with a factor of 10. There was also a strengthening of the limits for free transport of soil. There was also a put forward the drinking water limit, which corresponds to what is used in the EU. The emissions should be below the quantification limits. And for the air emissions, there is still ongoing activity to try to measure also the perfluorinated compounds in the stack emissions. How to communicate now to the public? Well, the communication to the public included that there is no acute effects expected from the contamination, but at the long-term health effects can definitely not be excluded. The other thing was that was communicated as indeed the limit values are strengthened, for example, for starting soil remediation, but they are not yet compatible with the new EFSA guidelines, the new TWI. So a health risk cannot be excluded. So it's very important to try to limit all further exposure and to really implement, where possible, the no regret measures. Also, the people have the possibility to have their serum analyzed to know what's in their body. There will be long-term health studies organized, and also the sanitation works in the remediation in the contaminated areas have been started. Also, the construction works will be very closely monitored, and Flanders and Belgium have committed to participate and support at the EU level further restrictions of PFAS compounds. What was now the response of the company? Well, there was a lot of discussion first, and first they were absolutely not happy, and they did not take it very seriously with the health effects. But after all, they decided, now they made an agreement with the Flemish authorities, and they will pay about 571 million euros to support the local farmers, to also start immediately with the most urgent remediation works, to support the Flemish authorities to work on the 3M site and the remediation in the vicinity of the 3M site, to help also to support also the constructor, and they also will not get any further subsidies. In fact, at the beginning of this year, they announced that they will stop all the PFAS production at the 3M site in Zwijndrecht. They said it was because of the stronger regulations and also the damage claims that they expected. So to recapitulate a little bit, a lot of things happened the last 1.5 years, from the moment when these high levels in topsoils were discovered. A lot of actions have taken place. For example, ban on discharge of wastewater. Also, some of the PFAS related production processes at the 3M company had to stop. Some lawsuits were initiated by the action groups against the authorities and also against the 3M plant. The construction works stopped for a while. They could start again after they adapted some of the processes, and they are very well monitored. Meanwhile, also there was an agreement made with the 3M company that they will pay about €500 million for the sanitation, and that they will stop the PFAS production in 2025. So to conclude, I think what we can learn from all this is, what we learned after all this is that, and you will hear that later on in the next talk, that the PFAS problem is not only a problem at the 3M site in Flanders, we have many PFAS sites, contaminated sites, but it's not on that we don't only have a problem with the PFAS, there are more compounds, chemicals which pose problems in Flanders. In Flanders, the industrial function, residential function, agriculture function, traffic, it's very much interwoven. So we have many problems, and we can, for the moment, not tell the people that there is no health problem due to the environmental contamination. And therefore, a long-term strategy has been developed, and there will be an action hub who will really try to work on it in order to have a more proactive, precautionary approach to try to deal with this type of problems in the future. By this, I would like to thank you for your attention. I really apologize for all what went wrong with my slides, with my slide presentation, but I hope at least you could follow a little bit. Thank you very much.
Yes, thank you very much, Greet, for this excellent and very interesting presentation of this current relevant case. Is there an immediate question? Otherwise, I would have one question. We have now a compensation of the company to the authorities. Is there anything ongoing about compensation also to private people? Are there also court cases, Greet?
Yes, there are court cases initiated, but they are still ongoing. So but there are private people and also some of these action groups who went to court, and these procedures are ongoing. But you are right, an agreement of 3M was made with the Flemish authorities. Mm-hmm.
Okay, yeah, thank you. Then we come to the presentation of Mr. Johan Ceenaeme from OVAM. This is the Public Waste Agency in Flanders. So this means also Belgium, where they have been very active in recent years. And his presentation will be on PFAS policy for soil and groundwater in Flanders in Belgium. Yeah, so please, Johan, you can start your presentation.
Okay, thank you for the introduction, and also thank you for the possibility to have this platform in the forum to present our policy in Flanders for soil and groundwater. And also, of course, welcome to all the participants of this PFAS session. So, as Dr. Schroeters already introduced, I think this presentation is also what has been happening from the authorities and from the competent agency OVAM to tackle the problem of PFAS in soil and groundwater in Flanders. I hope you can see everything on my slides, so, and also everything is going well, where I will give you an overview of the content of this presentation. I'll give you a short introduction what happened before the crisis, then how we made up an inventory of PFAS contaminated sites in Flanders, give you some insights on the first results of these investigations. And we have done the investigations preliminary for the fire services related sites. Then we developed trigger values for PFAS in soil and groundwater. And of course, we'll also have an outlook towards the future. What's next? What kind of knowledge do we need to go on with our PFAS policy? So, introduction. Well, we already started before the crisis, started in 2021. That was also what Dr. Schroeters told you, where we had the Parliamentary Inquiry Commission. We already did a measuring campaign on PFAS in 2016. because we had already had the experience and also the exchange of knowledge with other European member states or from the United States. So we made up an inventory of risk sites, and 24 sites then were selected for the analysis of soil and groundwater for 21 PFAS. What were the conclusions? That mainly and especially on firefighting training grounds, soil and groundwater were contaminated. Of course, we already knew that there was also contamination with PFAS at the facility of Ceenaeme in Antwerp. But mainly we expected it to be within the borders of the facility. Later on, it proved that also there was a contamination in the city of Zwijndrecht. So the conclusion of that first investigation was, of course, that PFAS must be included in as a suspect substance in soil investigations. There were some actions were started. So we did some preventive actions in collaboration with fire services organizations. We've already started to develop trigger values for PFAS in soil and groundwater. We made an identification, an inventory of PFAS contaminated sites, and we also developed guidelines for soil investigation so that everyone would know at the moment they had to do a preliminary soil investigation, for instance, with a closure, but also with the transfer of a risk facility in Flanders, you need to do a soil investigation. In what cases they also had to take into account PFAS and did have to do the investigation of PFAS. So what came out of it? Because we have an inventory of land with risk activities. It's called our local communities inventory. But what's special, of course, is that the use of fire extinguishing foam is traditionally not seen as really a heavy contaminating activity, so that it is not into our list of the risk activities. So we had a call to the local authorities. That was in July 2021, when the PFAS crisis started in Flanders, and it was the first part of the inventory, to have a look to all the places, the sites where fire service training was executed, where fire services facilities were executed, also the calamities and military training areas and airports, and also civil airports. And out of that inventory, we came that for Flanders, that we have 826 locations where fire service training sites and calamities. We did also a second part of this inventory was on the processing industry. And of course, we know that Ceenaeme is a producing facility, but as you all know, a lot of activities also use PFAS in their production processes. And we also asked to the local authorities to make up a total inventory of textile industry, paper industry, galvanic industry, and also we had some inventories that already were executed by the OVA. The result is that what we know for the moment, at more than 6,000 locations in Flanders are PFAS suspected. And the screening and the prioritization of those sites is still going on with 2 consultants. Mainly, we do their not investigations on the site for the moment, but it's mainly on the desk information that is available. Further studies will follow. What I want to focus on now is more the investigation we have done on the fire services related sites. We started that in July of 2021. We started with these investigations, and that were soil experts that were commissioned by the OVAM. So we did some 40 sites a month. And these preliminary soil investigations, we developed a specific protocol, because it's not, we saw that we already had to look more to the vicinity, so if to see if there was a spreading of PFAS from the site where the activity had taken place. So we had a specific protocol we developed for it. It was focused on PFAS. We did also limited sampling in the source area because it was clear to us that if you have used PFAS foams on a soil, that it is clear that you will find there a contamination. So we did more sampling at the borders of the source area to estimate the risks for the surroundings. We also make a decision on that investigation, whether a further soil investigation is needed, and we determined priority classes, depending, of course, on the amount of contamination we found, but also for the risks for the surroundings. And Dr. Schroeters already mentioned it in her talk, that we determined no regret measures by the Agency of Care and Health. So not only for the 3M sites, but all the surroundings of those 826 sites, we also had no regret measures from the Agency of Care and Health. What is happening after those preliminary soil investigations? Well, we of course have a lot of contacts with the Agency of Care and Health. And if there is a contamination where further measures is necessary, then we have an official request from the OVAM to the operator or the owner, and where we are looking to the polluter pays principle, to execute a descriptive soil investigation. So then they have to look to the investigation of the whole contamination and also determine the risks of the contamination, not only on the human toxicological level, but also ecotoxicological level and the spreading of the contamination. We will see that this is an important point, because we do not only find those elevated concentrations in soil, but we also find very elevated concentrations in groundwater. And there's also a part running where the Administration on Health is having contact with local authorities about the no regret measures. So you can also find those no regret measures in the database. And you can clearly see that there is a big area of some kilometers around the 3M production site. That was already explained by Grit. And of course, you have a lot of those other training sites where we have installed no regret measures. This is, of course, data that are available for everyone, and this is for public consultation. Then we also have the preliminary soil investigations on fire services related sites. They are also indicated in that database. What is the current state of affairs? As I already said, we have 826 firefighting related sites that we have in our inventory, and already on more than 600 sites we have started the preliminary investigations. Of those sites, 97 appear not to be suspected, PFAS suspected, and nearly 400 investigations are in completion phase, of which 268 are really finished, where we had our contacts with the Agency of Health, where we also informed the local communities, where the people were locally informed about the effects. So, but the investigations are still going on. For those 268 that have been finished, out of them, 189, there is a need for further action. So a descriptive soil investigation, and also possibly there will be a need of remediation. To put this clear, this is a rather high percentage. It means that nearly 70% of all investigated sites have to go to a descriptive soil investigation, possibly also to remediation. If we look to the investigations we do classically at other sites in Flanders, we only have a percentage of 30% who go to the next stage of investigation. So this is really high. It means that we find PFAS at most of those sites, and that there is also a possibility of spreading of this contamination. So to give you some evaluation of the results of those first preliminary soil investigation reports. So 68 reports were completely evaluated in this study. And what we see, and I already mentioned it, if we look to groundwater, that you see a higher percentage where the groundwater contamination is the reason why further investigation is needed. And only in a very limited case where you see that there is no further investigation needed when we look at the compartments of groundwater. And per site, we make maximum concentrations in soil and groundwater for the different PFAS. What we see is that frequently found PFAS parameters. If you look to soil, you have the 8.2 FDS, 10.2 FDS. Groundwater, you have the more mobile, of course, the C4, but also to the C8, as for instance, the P4. If you look to soil and groundwater, you find those classical parameters that are used in PFAS extinguishing foams, in fire extinguishing foams, so the PFAS, but also the 6.2 FTS. So there is a focus for further research on risk assessment, setting of trigger values. We also see that there is an effect, of course, of pavement, that there is a high variability in PFAS compounds. If you look to the more old extinguishing foams, it's more PFAS that is important. To the new extinguishing foams, you see the 10.2 FTS, 8.2, and the 6.2 FTS. But we had difficulties to see the difference because normally in Flanders, PFAS was not used or not frequently used anymore after 2011, but it's difficult to make that distinction. That difference. There's also a different composition in soil versus groundwater. So there is a complex leaching behavior. That's I think that a lot of people who have more experience with PFAS have already seen this, that there is a complex leaching behavior where we sometimes do not really understand what happens. To give you an idea of the fingerprint in soil, the blue bars are the PFAS, so they are still the main component of PFAS we find with those sites, but you have a lot of other components that also are also in the soil. If you look to groundwater, it even becomes more different. You still find the PFAS, but a lot of other compounds can also be found in the groundwater of those sites where they use the fire extinguishing foams. So we came in Flanders to develop the trigger values for PFAS in soil and groundwater. Normally, if you have those, if you look to soil, we have our background values, we have our target values, and those soil remediation standards are, of course, different depending on the use of the soil. So if you have nature agriculture, you have a higher level. If you go to residence, recreation, industry, that's a classical in our the way we do, of course, our risk-based soil investigation, soil also to have an idea of the risk that a contamination can pose. If you go to the excavated soils, well, we have the values for free use and then also values for construction purposes. And as you see, it's not only something we use for excavated soils. Since 2019, also sediments are part of the way we reuse our soil materials. What are the soil remediation criteria for PFAS in soil for the moment? That's applicable since 2022. Well, we have for nature and agriculture, we have the value of 3.8 micrograms per kilogram. And for residents, we make a difference between the residential area with vegetable gardens and free-range chicken coop. There you have to use the 3.8 as a soil remediation value. And for the residents without those uses, then you have a value of 18. For the higher, as the recreation industry, you have a value of 110, because we also wanted to take into account the leaching of those concentrations into groundwater. It's a temporary framework, to put it clear. It's not incorporated for the moment in our legal system. So it's something we advise, but it's followed by everyone in Flanders. If you look to PFOA, there are some same principles with values 4.3, 89, and then 643 for recreation and industry. And this is also applicable since last year, and it's a temporary framework. And for groundwater, our soil remediation criterion for groundwater is set at the European limit for drinking water. So this is a little bit different than what we normally do for our other soil remediation values. For other components, this is really stringent in that sense that we use the drinking water values of 0.1 microgram per liter for the sum of 20 PFAS and 0.5 micrograms per liter for the sum of all quantitative measurable PFAS. This is also applicable since April 2022. The background values and target values, but most important is, of course, the free use of the soils in Flanders. Well, there you have to fulfill the criteria of the 338. 3 for PFAS, 3 for PFOA, and 8 for the sum of the PFAS. For the use in construction purposes, there you have higher values, but that's the responsibility of the soil expert. There was, of course, a demand because also the use of excavated soils, the use of soil materials. There were also a lot of questions about the risk analysis because we still used the EPA 2016 and the EFSA 2020 had come. So there were a lot of questions to have more legal certainty from stakeholders. So we also took into account the EFSA's recommended daily intake. And so there was a new update of the framework was developed where you can see the values for PFAS, and PFOA. And to put it clear, still it's for nature and for agriculture, we take into account the background values. Normally, for nature and agriculture, you need to have lower values if you really want to completely to fulfill the EFSA criteria, but we have adjusted them because the background values and the target values, as you see, have seen on the previous slide, are already for PFAS, for instance, 1.5 micrograms per kilogram. For excavated soils, this is the new values we wanted to use, so there has not been so much change. Instead of the 338, we have the 328. But to put it very clear, this is the decision process is still ongoing, so this is not yet final. The Flemish government has given its principal first approval of this new framework, but it's not in the legislation for the moment. And then to conclude, what's next? We want to have an outlook towards the future, because it's very clear that there is still a lot we don't know about PFAS. And certainly, if you want to develop a policy for PFAS on soil and groundwater, you need to have more information. And so these are the actions and research activities that are going on. We are looking to the leaching of PFAS from soil to groundwater with experiments and also with modeling. We are also looking to the diffuse presence of PFAS in groundwater in Flanders. We already have an idea of the diffuse presence of PFAS in soil in Flanders, but it's not so clear what we will find in groundwater. We also have development of methods for dealing with the sum of PFAS in action frameworks, and was already presented by Dr. Lange. There are a lot of questions about also the analysis of PFAS. So this is for us also an important point. The characterization of PFAS in soil and groundwater on sites with different risk activities using non-target methods. Also, and this is an important point because we are sometimes really focusing, and it's also the same in Flanders, on soil and groundwater. But if you have some measurements of PFAS in house dust, and you see what is the contribution to exposure, that's something I have the impression we sometimes forget. There has been a study in the Netherlands where there have been background concentrations measured in house dust of 100 to 300 micrograms per kilogram of PFAS. So these concentrations, as you have perhaps seen also of the surroundings of 3M, while these concentrations in house dust are higher than what we find in the soils in the surroundings of 3M. And finally, I want to conclude with that. We have a lot of international knowledge exchange. OVAM is, for the moment, is having the network MConsol. We are organizing different conferences, the ENSOR conferences. Last year in October, we had the 4th conference, and with the EU presidency of Belgium in the beginning of 2024, we will have our ENSOR 5 conference. We don't have a precise date already, but you're welcome to that. So thank you for your attention, and I'm open for questions.
Thank you, Johan. So this will conclude the first part of the PFAS session. We will have the second part after 12 o'clock. And also there we have time for questions in the second part. Because now John Fagan will introduce another issue of the mayor. John, and you can start. Huh? Can you start a microphone?
It's working. Yeah, it's working.
Okay. Yes.
So I would like to make a small introduction for Mr. Paweł Silbert. Okay. Yes. So I would like to make an introduction for Mr. Paweł Silbert. He is the mayor of JAWORZNO. And JAWORZNO is a town in Silesia in Poland. And this town is confronted with a huge problem of lindane. And he has been working many years for this. And he has been in our last project, HCH, which finished November 2021. He went to the European Parliament and tried to lobby and see for some help for him. And now he's here. He made time free, just this short moment, to address you and see how he can move on, because also the Polish legislation has been changed. And the blackjack, the responsibility is now as a only with the municipality. So this is very difficult, but at least it's clear now in Poland that somebody is responsible, and of course he needs help, but he is trying to move things forward. Paweł, are you there?
Thank you, John. Dear friends, the host of today's meeting from Zaragoza and the rest of you guests, I would love to be with you in person, but today we also have an important meeting of the City Council. During my speech in the background, there will be a presentation on chemical waste landfills in JAWORZNO. I will also tell you a bit about us and what has happened recently. JAWORZNO is one of the several cities in Poland affected by the difficult legacy of the production of plant protection products and its dismissive approach to natural habitat protection. The first production began in 1928 and lasted continuously for several decades. More than 42,000 tons of waste from the production of HCH have accumulated in our city. It is worth mentioning that this is still only a fraction of other hazardous chemical waste. Today, although the toxic heaps have overgrown, we are still suffering the environmental consequences of the robbery, and the accumulated waste is a source of enormous environmental contamination, including surface and groundwater. They pose a direct threat to people living near the chemical plant site. But that is not all. In the FOX project, scientists have proven that poisoned water pose a real threat to the catchment area of Poland's largest river, the Vistula. For many years, the team I work with has been taking action to tackle this problem. In addition to research, testing remediation ideas, some of which are very promising, we have been pointing out the need of legal regulation that could enable formal and effective action to address this gigantic problem. Such an opportunity has finally presented itself, but not in the form I expected. For several months, the Polish Ministry of Climate and Environment has been working on law on large-scale degraded areas. This law is dedicated to the most environmentally hazardous post-industrial sites located in cities: JAWORZNO, Bydgoszcz, Tarnowskie Góry, Zgierz, and Tomatów Mazowiecki. Each of these sites faces different problems. However, the common element is the presence of extremely toxic chemicals that have an extremely negative impact on the environment. The draft law on large-scale degraded areas is an extremely valuable and important initiative, but it shifts the entire organizational and financial burden for remediation activities to the municipalities where the waste is located. I'm in contact with colleagues from other cities. None of us are shying away from shouldering the remediation work, but financing this work, due to its enormous cost, is too much of a financial burden for our cities. There is the possibility of obtaining funding from various sources to solve the problem, but there is always the question of providing our own contribution, which, with the cost of environmental protection, perhaps even reaching several hundred million euros, is beyond our financial possibilities. In our case, due to decades of neglect, the process of cleaning up the contaminated groundwater in the valley of the Wąwolnica stream may take as long as 20 years, which will generate considerable resources, and in the absence of the provision of funding by the Polish state, will burden the residents of Jaworzno and hinder the city's development. This is why I have already requested several times that, under the auspices of the Ministry of Climate and Environment, institutional support be created for the cities involved in the problem, including the establishment of a team comprising representatives of ministry and the local authorities concerned to develop a strategic action plan against chemical pollution. A document in which we will jointly define a plan of action for combating chemical pollution, principles for carrying out monitoring, ways of minimizing risk for the nature, a comprehensive system of monitoring and early warning of pollution, and a multi-year program for financing individual tasks. This should be modeled on your strategic action plan against lindane pollution in Aragon, a model program that identified a multi-year remediation plan for areas heavily contaminated with hexachlorocyclohexane isomer. I've worked in local government for more than 20 years. I can say that I introduced JAWORZNO to the EU. We have been very successful in obtaining European national funds for various projects that the city has always needed. I avoided occurring and spending money on white elephants. Together, we have overcome the problem for over 20% unemployment. Today, JAWORZNO is a completely different, more beautiful city, largely thanks to EU financial support. I was also the initiator of legislation to deal with the problem of chemical waste, the European hotspots that are a legacy of the activities of state-owned plants. And now, while there is hope, with it comes danger, responsibility for future actions for which the legislature does not want to provide the cities with money, even thought they were not the perpetrators of the ecological disaster. I believe that there should be statutory financial support from the Polish state to ensure at least an own contribution to future programs supported by the EU and from money from the national fund. The organizational cost, the substantive contribution we are able to bear and provide, the cost of actual remediation activities would be lethal for us. I admire the determination, consistency, perseverance, and effectiveness of our Spanish friends. This is the approach we need in Poland. Common concern and the responsibility of all stakeholders. Now is your time. You fully deserve it. We really want to follow you and learn from your experiences. I remember very well John Wilhelm's presentation in Brussels, especially the part when you showed us how remediation costs increase over time. John, it was very accurate, concrete, and wise speech. Many years have passed since our first meeting, and at that time, day after day, a lot of water was constantly washing chemical waste and got into Vistula and with it into the Baltic Sea. And this has been going only 4 years, but it doesn't have to. Perhaps we are quite close to permanent work on full protection of the waters of the Vistula catchment. Perhaps we will be able to raise funds for the full disposal of this waste. But we will not do it without the understanding and real help of our government. Now is the time for the knowledge, ideas, authority of John and other experts, examples from Zaragoza and other comprehensive solutions gained so far, to inspire our political authorities so that the new law does not give us false hopes and shift the responsibility to local government without any hope to take responsibility. John, I'd like to see you on the negotiating team with our ministry. I feel if you are invited, you will not refuse. I feel if we ask, you will not refuse to show that this difficult legacy can be dealt with. Please support our efforts with examples of our solution, showing that even gigantic problems can be solved with joint efforts. This can help inspire the necessary courage in decision makers to take real action. If you have any questions regarding technical issues, my colleagues will answer them after my presentation on chat. Thank you very much.
So thank you for inviting to this meeting today. I would have loved to go to Zaragoza, but I'm happy that I can present online. I want to talk about the critical role of reference standards in the risk governance of chemicals in general, but with the example of PFAS. So first of all, I mean, we also heard today that we've seen the European Green Deal with a focus on zero pollution ambition, and also with the chemical strategies of sustainability that focuses on making chemicals safer and sustainable and try to avoid creating a lot of pollution that we have to remediate. However, this is part of a larger risk governance of chemicals that requires some methods and evidence. And what I'm going to talk about today is how we really need chemical standards in order to achieve this. With the chemical strategy for sustainability, that was focused on being aware that emissions occur along the life cycles, not just in the use of chemicals. It's both in the production, in the manufacturing, into products, during the use of the products, and then also in the waste management or in the recycling of the materials. It had a special focus on bioactive and very persistent chemicals because they tend to create most of the harm we have seen historically, including many of the examples you have shown on the chlorinated pesticides and other chlorinated compounds. And therefore, there was a focus on the very persistent chemicals, the example of PFAS highlighted. It asked that PFAS should be addressed as a class, that we should only use them if they're absolutely essential for society, not just economically, and that we should try to address them by regulation. And we have seen now that we have PFAS restriction, which was launched for comments by February 7th this year, and we already heard something about that. And also the focus on the need to update legislations accordingly. And as part of that, we have focusing on soil. There's also a call for addressing PFAS in soil and water, etc., and that we need to increase monitoring and reporting of PFAS. So the example that I want to give today was the case of PFAS called C604. You see it here on the right. It's a perfluorinated ether. It's one of these so-called replacement chemicals or short-chain chemicals that have replaced some of the perfluorocarboxylic acids, fluorophilic alcohols, and PFAS, or perfluorosulfonated alkyl acids. And we have looked into, well, the case on the C604, and I will go more into that, was a case where sorry, I'm very disturbed by this echo. I don't know how to move. But in any case, the C604 was a newer compound, and originally Wellington produced this chemical for as a reference chemical, but was at some point blocked in selling it. Looking into this situation, we've seen that less than 2% of more than 5,000 PFAS are commercially available as reference standards. And this, of course, poses a very big challenge for those who are trying to monitor and find emerging contaminants, but also trying to control existing regulations. So let's have a little bit of a closer look at the case of C604. Well, in 2011, the Solvay Special Polymers, they registered C604 in the REACH portal. And in 2014, it was approved, actually authorized by EFSA as used as a dispersion agent for making fluorinated polymers used for contact materials. This can be seen as a replacement for PFOA, for instance. And then jumping ahead to 2019, Veneto region announced that C604 was found in the Cook River, and the chemical provider Wellington announced that certified C604 standard. However, then Solvay took measures in 2021 to press charges against Wellington, saying it was infringing their patent and that they could not be allowed to sell it to, for instance, environmental analytical chemists unless Solvay authorized it. Basically, it meant that only the authorities in Italy could use it, but nobody else. Right now, there are some further developments. So now the more open towards releasing this chemical. But of course, it was a big concern for Wellington, but also other analytical chemists, because if you cannot buy the standards, it really blocks you from doing a lot of the analysis. And recently, it's also been found that C604 has been found in eggs and wild birds within 3 kilometers of the fluoropolymer plant, but also in wild boar and also other PFAS substitutes. So how is it that we need, and why is it that we need these chemical standards? Why are they so critical? Well, first of all, we need the chemical standards because we need to calibrate our analysis. When we have, when we do analysis, we create a signal, but we need to know how much does a peak height, for instance, correspond to in terms of concentration. So we needed to calibrate our instruments to know when we find this signal, what does that correspond to for concentration. We also need the chemical standards because once we have found a peak, for instance, it's still just a signal. In this case, what I showed here is mass spectrometry. And then we need to have the sample. We have a spectrum, but we need to compare with a chemical reference standard to know that it is exactly coming from that compound. At least that is how it is now. And then we also need to have chemical reference standards, first of all, to study what is the hazard of these compounds, how potent are they, what types of toxicities are they. This can be done in vivo, in whole organisms like mice and rats. It can be done in vitro with cell-based. And once this is done, you could start making in silico models that mimics how the responses are, and then go ahead and do modeling like QCs. But first of all, you need the reference standard to know what are the toxicities to train your data set. And so taking a look at the chemical risk governance side, this is done by the International Risk Governance Council that have summarized not just for chemical risk, but in general, how risks are governed. And here I want to show you where we need these reference standards. If we start at the top here, we have a pre-assessment, and this is the phase where we are trying to understand a problem. This would typically be when we first detect something. It's used for early warning screenings. We kind of frame the project, the problem, and want to understand what is the extent of this. Should we go further ahead and do risk assessment? Here we could use methods like the ones that Dr. Lange showed, group methods. We can use suspect untargeted screenings. There's always the question of whether we see it all or only see some of it, if not everything is extracted. And then that, of course, reminds us that no data is not equal to no harm, because we might miss them. But often here we would be asked to confirm that what we have found is actually the compound we're looking at, and this is where we need chemical standards. At this stage, you might also often be asked to give an estimate of how much is there of it, so you could be helping your prioritization. And then optionally, you can do hazard characterization if you have a standard, but often if you don't have a standard. Let's say that you then have decided, okay, there's something here we want to look further into, then you can move ahead with risk assessment, and this is confirmatory analysis. Here you'll be asked to provide information on actually how much do you find of the substance, of what is the concentration, and for that you need the chemical reference standard. Also, you would need to characterize the different types of hazards, and again, as I showed before, you would need the standards for that. And that would then later feed into the concern assessment, but if you have a lot of uncertainty about whether it is actually the chemical you're looking at, what is the concentration, it's very hard to convince the public and politicians that this is something you take serious and do something about. And this is just very similar to also what Dr. Lange showed you. If you look at the environment for what is out there, you can look for just identified fluorine with the limited number of analytical standards we have, or you can expand it into extractable organofluorine and total fluorine. And what you see down here is a study done in the Nordic environment from 2019 that studied fish, marine mammals, bird eggs, and terrestrial mammals. And what you see is the white, which is identified PFAS, and the black was unidentified PFAS. And I should say that here, the identified PFAS was actually more than 50 analytical standards, which is more than typically is analyzed. So they really try to use all the standards available. And still you can see, especially in the terrestrial area, that you have a lot of PFAS missing, or at least you have a lot of unexplained total organic fluorine. Once you then have done the risk assessment, you might go ahead and say, okay, now you know what risk is, and then you have to decide what to do there. And this is the decision-making part. And here it's really the choices, which approach to address the risk. It depends very much on how certain you are. And there again, the more certain you are, the more likely there is some action will be taken. And targeted methods will often require reference standards to trigger action. But there will also be some considerations of, like, it's practically economically feasible to clean up the site, balancing other risks and also other of the funding. I mean, if you don't have the money, you might not be able to clean it up. And if you cannot clean up, or if you don't have the standards, you might have to consider other risk management options, and also pass on the costs to the polluter, if possible. And then finally, after this risk governance cycle has run for a while, you might decide that you need to set limit values, and those limit values will then need to be implemented, and you might go ahead and do some monitoring for indicators, might want to go and enforce the limits, and for that you need enforcement methods. For the enforcement methods, you need to have sufficient quality assurance and robustness so that you can trust the results and respect the outcome. And here we need precise methods. And precise methods is good enough to check for compliance with limit values. And that means that typically you could use targeted methods, but you could also use group methods. And this has been used quite a lot in the past for metals, for instance, but also for organochlorine compounds, for primary acid amines and others. There are group methods that have been used also for enforcement. And then it's very typical that you have some decision charts in case of non-compliance. And so you can take a decision on what to do and who should take action, who should clean up, who should pay for it, how do you communicate, etc. And you need to train personnel in how to use the methods and the data and how to communicate it. And all of this can then lead to the final assessment of the effectiveness of policy. And what the last arrow shows, going back into the circle, is that if you find that your policies have not been effective enough to prevent pollution, for instance, you might go back and have to look at the underlying regulation. Do you need to take further measures, such as restricting? So in these cases where we have a regulation that really requires that we have reference standards to actually provide the evidence and to implement the regulation, what can we then do when we don't have it? Well, first of all, we could say that the lack of the evidence really hinders our ability to generate the evidence. This calls for a consideration of whether we should take regulatory measures to increase and secure access to reference standards. For instance, the revision of REACH could be one way to go, but there could also be vertical legislations where you might be able to require such availability of standards. There's also an option to do some gap filling of missing data in a way that creates incentives for companies to supply the standards. So, for instance, if your risk assessment assumes a worse risk if you don't have standards, that might actually create an incentive for the companies to provide the standards, so you would have an assessment of a lower risk and therefore lower measures. Right now, we have the tricky situation that if you want to do modeling, you need data on which chemicals are used and which hazards they have and uses, but all of this depends on the type of chemicals. So often you don't have enough information to do filling as it is right now, at least not for low tonnage chemicals. But it may also open up for the discussion of which data is sufficient for which decisions. I mean, our regulations are in a way formed around an assumption that we have access to standards. For instance, like pesticides, veterinary drugs, there we do have standards, and a lot of the guidance documents of amount of evidence you need to take certain decisions and you know, pull, give fines, etc., are assuming we have these. But in the environmental area, we often do not have that, and perhaps we have to reconsider which type of evidence is sufficient for taking action. So, for instance, for exploratory analysis or the first pre-assessment step, it might be good enough just to use group methods, semi-quantification by suspect and non-targeted analysis. And for confirmatory analysis, so when we do the enforcement or risk assessment, right now we need a chemical reference standard, but could we actually say that if we don't have that standard, it might be enough to accept semi-quantification, a little bit lower certainty of chemical identity, and still take action on it. So these are some of the open questions that I think we have to face because we just don't have the standards. And now I just want to switch over to another topic, an example of how we foresee to use this approach, because we have been pre-awarded a big grant called Aragon. It's an EU soil mission project under the Fund for Horizon Europe. The aim here is to provide tools for landowners to decide when and how and to restore nature on polluted soils. It focuses on persistent pollutants and hotspot polluted areas, and we need to be mapping where such hotspot polluted sites may be based on where the chemicals have been used. And here we want to use different types of analytical methods such as grouping, targeted analysis, non-targeted analysis, as well as other methods, but also socioeconomic assessments, and see which type of data can we use for which type of decisions. And all of this will then eventually feed into some decision flow charts and guidances we'll produce to support future landowners. It consists of 17 partners, 12 European countries. Here at University of Copenhagen, we are the project, I'm the project lead. And it's a project for 6.6 million euros plus about 1 million euros from Switzerland. And if we are granted, we're still in the grant negotiation process. It will start October 1st and run for 4 years. And just to give you a little bit of an overview of how we foresee that the whole process will be running in the project, you see this is taken from the risk governance cycle that I just showed before. We will start with some pre-assessment where we map polluting activities and create GIST map, and also consider, you know, what is the available funding in the local context. Then go ahead and identify risk and hazards, characterize them, and move into some socioeconomic assessments. And all of this will then feed into the decision-making part where we will evaluate the risk tolerance also in a local setting and the need for risk mitigation. The need for risk mitigation is where it gets a little bit interesting, because sometimes you might not be able to actually remove a remediation or remove a pollution, and you might just have to prevent it from spreading further. But of course, that also depends on whether there are very sensitive areas of drinking water interest, etc. And finally, then we foresee to bring it into, again, the local context and collect all these informations for advice at the EU policy level and also at national. And of course, we're very interested in collaboration because we understand that there's a lot of knowledge and experience on soil pollution and how to run these projects. And it also varies a lot in local and national context. So really, if you have both ongoing projects or past projects, we are looking very much forward to receiving an email from you, and we would be very interested in collaborating and also to bring your data into our maps. And we're aiming to make all the maps interoperable and compatible, for instance, with the information platform for monitoring, so everybody can access the data also in the future. So in conclusions and some outlook, we have a current situation where we have a lack of access to chemical reference standards that are actually needed to generate the evidence needed to govern the risks of chemicals. This hinders the detection of emerging contaminants, but it also hinders the risk assessment and the decision. And I think it's about time to consider which data is sufficient for which decisions, and hope that there will be an open discussion also with the revision of REACH. For the Aragon EU soil emission project, we developed a decision-making scheme and guidances to support the landowners to enable them to prioritize when and where to remediate and restore nature, and in some cases maybe just the pollution. And we really hope for your collaboration. And with that, I want to thank you for your attention and hope that you will enjoy the wonderful area of Aragon, not Aragon, and thank also the contributors to this article that we have submitted, Stefan Verleuven, Gianfranco Gravio, Roland Weber, who's there, and Thomas Webster. Also Wellington Laboratories for providing insights in this D604, as well as a lot of other collaborators and the great team. Thank you very much.
Thank you very much, Xenia, for bringing up this very important topic on the analytical standards. Yeah, and I mean, you are looking for networks and for possible partners, and I think here in this conference you might have really perfect partners. I mean, the IHPA network and also the people here in Spain working on these large-scale contaminated sites, because if I understand you correctly, this Aragon project will be not only on the fluorinated contaminated sites, but also on chlorinated contaminated sites like the HCH sites.
Yes,
right?
You're right, exactly. So we focus on persistent compounds. So that would cover not just the PFAS, but also organochlorine compounds such as chlorinated pesticides, legacy chlorinated compounds, metals, and also petroleum and coal, so petrol compounds. And we are focused on that because they tend to be those that stay for the longest time, most issues. And there are still many hot site polluted areas that need, yeah. And if you're interested, please put your contact details in the chat and we could get in contact with you.
Yes, and I will link you with IHPA people, yeah, including also the authorities here. Are there questions in the room? Yes, please. Pim, maybe you can also shortly introduce yourself.
Yeah, hi, Xenia. Thank you very much for this nice presentation. I fully agree with you that we need standards. I only want to make a comment. We are working on a European project which is called REVAMP from the Vrije Universiteit in Amsterdam together with Chiron, and we are working on many new standards. So there will be more standards coming available, not only for PFAS, but also for chlorinated paraffins. So it's
Wonderful.
only a remark. It's called REVAMP.
Yes. Would it be possible that you put your email address in the chat and I can get in contact with you?
Okay, great.
Thank you very much.
Yeah. I will give Pim your email address, so I think you know each other. Are there other questions to Xenia? I have one question. I mean, this Aragon, I mean, the name itself, has this to do something with Aragon? You know, we are here in Aragon where you have huge, this HCH contaminated sites. So is this somehow linked or is this just coincidence?
Actually, this is just coincidence. But when we thought about a good name, we wanted to think of somebody who could be a protector of Earth, you know, and nature. And that was how we thought of Aragon from the spring section.
Okay.
And also he's a long time protector, you know, like
yeah. Okay, good. And we have later more time for discussion. Now we would come to the next presenter, The next presenter is Dr. Dietmar Müller Grabherr. He is the chair of the Common Forum. This is the organization of the European authorities working on contaminated land. He's also in the Environment Agency of Austria. And his talk will be Forever Chemicals versus One Health, PFAS, a call to rethink how we manage contaminated land.
Thanks, Roland. Buenas tardes, Zaragoza. I'm really puzzled that Zaragoza will receive snow while Vienna is staying with springtime. First of all, my congratulations for the conference organizers for organizing such an informing session, and I hope the whole conference will be. Me here to will contribute for the session on the forever chemicals. While our societies still seek or have the new idea of one health, so there is no division in between the human health and the environmental health, we should think. And the example of the substance group of PFAS is the perfect call to rethink how we manage contaminated land. Well, just to let you know what Common Forum is, it is a network, an informal network of policymakers and regulators in place since more than 25 years. We are not only European Union, but also involving the European Free Trade Association and further guests. You have seen today Johan Ceenaeme and Joerg Frauenstein. I want to thank both of them. They are taking the effort to lead the PFAS team inside Common Forum.
Can you go a bit more close to the microphone and speak a little bit slower? It's the tone here in the room is a little bit weak.
Okay, so I will slow down. Well, Common Forum here again. My wish to thank Johan Ceenaeme and Joerg Frauenstein, who are the leaders of the PFAS team inside Common Forum, taking that effort. Me, I'm the general secretary, so perceive me more as being the spokesman of the network, not the perfect expert in PFAS. What we're looking for is organizing knowledge and experience exchange, and also to cooperate with any stakeholders, be it the industry, be it the European Commission. Well, in my presentation, I just want to go back, well, think about where PFAS, where did the story really start? Briefly touch on typically environmental legacies. Give an overview, what's the status quo, which poses the basic question, if our societies already crossed tipping points in chemical pollution. But finally, also to come up for the future, what we need in contaminated land management. Well, PFAS, when did it start? It's now more or less, let's see, more than 80 years ago that Teflon was discovered. And some 30 years later, it made us going to the moon. So there are advantageous properties we are making use of. Nevertheless, if you look for science and toxicology during the last 10 to 15 years, it moved much forward. We came from the single to the multi-compound assessment, and what we observed was an exponential decrease of toxicological values tolerable daily intakes, which then also is the background why we already know a lot of real big environmental damages. Here you see kind of a personal selection out of the Common Forum region. Well, there's Italy, where you have 30 kilometers groundwater plume, and according to WHO, impacted drinking water for more than 300,000 citizens. You've already heard about Belgium and Netherlands. all these three countries, the contamination stemmed from production plants. If you go over to Germany and one of the most prominent sites there, that's a different story. It moves over to diffuse pollution. It was caused basically in Rastatt by application of sludges in agriculture, and the sludges have been contaminated by a paper mill or the wastewater of a paper mill. And there is also evidence for human health effects, which brings also here then the first idea that all our colleagues around Europe in the regulatory bodies work towards solutions. So as an example, the report published by the German Federal Environment Agency for managing not only local but landscape PFAS contamination, if you try to translate. And you find further examples all around. It's really environmental contamination. If you look for Scandinavia and the fjords and estuaries over there, you find there are a lot of contaminated sediments and biota, and airports, of course, up to the Arctic regions, it's even more a problem. Besides environment, there was also, just to highlight, an initiative on human biomonitoring last June 2022. The project published its policy brief. Here you see and read out for the key messages. And the key messages, if I summarize, there is real evidence that 1 out of 10, or even in some countries 1 out of 5 of our youth already has a real serious internal exposure against PFAS, which likely stems from different food sources, which often relate to the blood levels. Also here, then let's go for regional PFAS background levels. So that's not human, that's not the big damages, but really trying to understand what's out there. Also here in Austria, we try to make our exercises, making the story brief for the soil investigation in the most western province of Austria. We needed to realize, yes, there is an ambient background concentration. It's for the PFAS in question. We investigated about 1 microgram per kilogram of soil, and it's also mobile. So what brings up that the soils, well, they are kind of contaminant sink, but only at an intermediate time frame. Going more global, you have already seen the figure on the left-hand side about rainwater around the globe, and also seeing the comparison against the Danish drinking water standard. What is to be observed is, if you look for the drinking water standards at the European level in comparison to Denmark, there are orders of magnitude in between, and there is a difference in substances considered. And since last October, there is also a new proposal out for environmental quality standards in the European Union. Here again, a different number. And here again, a different set of substances to be considered. So this really brings serious challenges to all people involved, I would say. And well, you see also the citation of the authors for the rainwater investigation, concluding that it might be beyond the planetary boundary for chemical pollution. Well, I feel it could be. We need to more discussion and also data. So regulating PFAS, so the questions and concerns, we also in discussion to citizens and stakeholders, that's what we are doing. So how to really deal with when values differ about 2 orders of magnitude. You need solutions in legislation and also for different substances that creates really tension in the system. And then if we come up with environmental quality standards, we also need to look out, we need to communicate to clearly what is the meaning to our citizens. So an environmental quality standard is, to me, let's say, is where if it's not exceeded, it's good. Above, then we need to investigate and think about how to deal with. And then you, of course, in stakeholder discussions, in particular on the new proposed water and BELGIUM, like EQS, well, there are a lot of arguments about, well, it's unfeasibly low, it's often below ambient levels, obviously. Science gets questions also, but what we discuss in Common Forum, yeah, if we go there, that can get a significant barrier in the redevelopment of land. And well, we had such stories already, it might be showstopper for businesses, so like in 2019 in the Netherlands, or if you go for fisheries, or you can do a long row of examples. Summarizing, what's the state of PFAS in the environment? Well, we have a long-lasting evidence. We need to face that it's not only point source inputs, but it's diffuse inputs to soil and water. We also need to simply accept that background values may exceed in some regions environmental quality standards. So there is something already out. We cannot go back to the last century. And what is really a pity is that data and information are really heterogeneous and incomplete across Europe. So it might be, well, we will have some irreversibility in the system. That it is hard to treat contamination, and well, our needs during the last years, like also explained by Johan and Ceenaeme, are getting more pressing every year. So here, this team of learning in societies or groups. So it's not only we will need this inner circle where you have only improve your actions by learnings. And it's not only that we reframe by legislation, we really need to look out for something like nonlinear thinking and transforming to a new thinking. What we also will need to control and it is a societal challenge, I think, but still it's not too obvious, although there are reports out that we share a sense of urgency. The sense of urgency in biodiversity has increased during the last years. I'm not sure we are on the same level for chemical pollution. We have policies framing this. You see here this already seen figure out of the Zero Pollution Action Plan of the European Union. Not explaining something deeper, but what I feel and what I call for is also that the green upper part and the prevention part and the red dirty part to the bottom where my colleagues are working, we need to get closer in information exchange in future and to be more aligned in our actions. What Common Forum did already more than 2 years ago was we published position paper, and we directed it to the European Commission in Brussels and also to other governmental bodies. We call upon Europe. It's really a problem at any scale, from sites to the global region of Europe. What we need, you see, we established 4 or 5 key requirements. We will need new high standard risk assessment and contaminated land management. But not only, we will need and make use now of new technologies, maybe for validating our risk assessments also by biomonitoring studies. In terms of remediation methods, it's a call for we shouldn't all 27 countries in the Union develop technologies and approaches. We should do it transnational together. We are all in the same boat, in the same situation, in the same problem. Besides that, we need to respect also and to be aware that technically means will have their limits and will need alternatives, which also need to be embedded for the policy and legislation. Finally, as emphasized before, with the environmental quality standards and other trigger values, we really need also a harmonization of regulatory approaches. PFAS that's really also some cross-cutting about soil, waste, and groundwater. More general reflections. So the basic risk management challenge is we still have uncertainty, complexity, and ambiguity, everything we want. And if we deem ourselves or wish ourselves to be knowledge-based societies, we also need to look for much quicker transfer and communication of research findings to embed them to administrative implementation. And finally, in all our dialogues, we need transparency, and we need to develop a good common understanding to avoid distraction. Whatever you can see, there's a challenge or a crisis in PFAS. The question that really matters is who will take leadership. And coming back to what already has been introduced by Xenia, the framework for risk governance, it also suggests this figure. So you see the characteristics of risk problems, the actors, and PFAS is not at all a simple risk problem. It is complex, but even more, it involves still reasonable uncertainties and for sure ambiguity. And then at the end of the day, it simply calls for all societal actors to work together. So that's it from my side, Roland. Thank you for listening and open for questions.
Yes, thank you very much. Yeah, Dietmar, for delivering your presentation. Also, you are ill since a few days. Are there questions from the audience? Otherwise, I have one question. You said that environmental quality standards, you were doubting the scientific quality. Are you referring to the 0.65 nanogram per liter of PFAS, or are you referring to another environmental standard?
No, just to avoid it. Thanks for questioning this. Roland, it opens the door to clarify. And the clarification is simple. So that was not my personal opinion. That was a citation from a lot of discussions I'm facing. And it's coming from different angles, from different stakeholders. So this was simply to highlight what is out there in the coffee breaks, what I experience.
Yeah, because I think the 0.65 for PFAS environmental quality standard, when you look now for the limits in fish, yeah, I think it has to be quite low in respect to human exposure. And this was also the way how REVIM derived this 0.65 nanogram per liter. Yeah, so therefore I think that this might even be the appropriate limit, most probably, when you look to the EFSA health tolerable weekly intake. Yeah, other questions?
Well, just to comment from my side for the PFAS, well, I would say that's not too much shaky ground. What is nowadays the most concern are the 4.4 nanogram per liter as an environmental quality standard in groundwater in future in Europe for 24 substances.
Okay. Thank you, Dietmar. Now we go to the next presentation, and we are proud to announce Ms. Stéphane Horel from Le Monde, representing the journalist consortium of the Forever Pollution Project. We all know that we can talk about PFAS and the contamination within our technical groups, but it's very important that we reach out, and it's very impressive what the journalist consortium has achieved and what they have published today in multiple newspapers across Europe. So, Ms. Horel, the floor is yours. We are very much interested in what you have to present.
Thank you.
Okay, thank you very much for having me a layperson in your scientific gathering. I'm very honored to present our results, and I will just try to be able to actually do it because I'm not very much used to this kind of things.
Yes,
so can you
yes.
see my presentation?
Yes, you can. Yes, and you are in presentation mode perfectly.
Okay, good. So I'm very proud to present to you what we call the cross-border investigation project, which is a project we investigated in 17 countries and around 25 journalists. It's a project called the Forever Pollution Project, and we started it almost 1 year ago with the aim to map PFAS pollution across Europe. So these are the media partners. Some haven't published yet, but it's I think major landmark publication in terms of environmental investigation, because it's an underreported topic. Chemicals are underreported in journalism, and this kind of project, cross-border work with the work grants that are favoring this kind of collaborations. So this is what we published this morning on Le Monde's website. We called it the map of forever pollution. I'm going to explain to you how we made this and what are our main results. And so, as you can see, we have 4 categories on the map. We have known contamination, known PFAS users, presumptive contamination, but also PFAS manufacturing facilities. The starting point of all this was this report that anybody who works on PFAS knows by heart, because it's a reference, it's a trove of information. And there was this table listing PFAS facilities in Europe, and the footnote saying it is assumed that there are between 12 and 20 facilities. So we thought, let's find the 8 remaining facilities, or maybe more. But this was the starting point of our investigation. 1 year ago, only 5 media partners, and with the idea to locate and put on a map PFAS producers in Europe. So that's how it started, but as you know, it's not how it ended. because soon after that, we came across the amazing work that was done in the US by the PFAS Project Lab to map pollution, PFAS pollution in the US. And what was extremely interesting in this work was the two layers: known contamination, but also presumptive contamination. And the difference between the two is non-contamination sites, sorry, are sites where samples have measured PFAS levels in the environment, and presumptive contamination sites are sites where contamination is likely given the activity that is taking place there, whether it's an industrial activity or firefighting foam contamination place. I will go into more details about this. But so at the beginning, we saw this map, and in the course of the project, the team published their peer-reviewed methodology on explaining how they developed this presumptive contamination sites methodology. And we contacted them from the very start, and we asked them some help to adapt their methodology to Europe. So that was quite an adventure, because we are only journalists, we're not scientists. So I wrote a methodology which has constantly evolved in the past month, and last edits were made last night before it was put online. And it describes step by step what we've done, because the idea I had, I've been working on chemicals for 15 years, and I am aware of how scientific work functions, and I knew that in order to do sound work, we needed to report everything, every step we had done. One other idea was also that we were pretty much aware that we are only journalists, and but we didn't want to do sloppy work. We wanted to do something that is useful, that would, of course, be imperfect, but that could be improved, and offered to the scientific community and to regulators to help deal with this major pollution problem. And so we invented a new type of journalism that we called peer-reviewed journalism, in the sense that we had four scientists from this US map team who helped us, but also Ian Cousins, Greta Goldenman, who led the cost of reduction report on PFAS, and Martin Scheringer, all our major specialists in PFAS. And we thought, let's ask the best scientists we heard of to advise us, and sometimes step by step they helped us adapt this methodology, because it was not possible to duplicate the methodology and adapt it to Europe. So the first result we have is we have managed to locate precisely 20 PFAS producers. This is the list that you have in front of you. 3 of these facilities are inactive, but given the eternity of PFAS pollution, it was important to keep them on the list, such as Miteni in Italy. But there are 2 that are completely under the radar, which is the Polish facility of Grupa Azoty, which is the #1 chemical company in Poland. They manufactured for decades a PTFE called Tarflen. And then the Arkema facility in Spain, Zaramillo, which was a facility manufacturing F-gases. The way we worked to identify those producers is both very simple and extremely time-consuming. So we used many sources that are all mentioned in our methodology, but we used companies' websites, annual reports, safety data sheets, ECHA list of PFAS registrants, And in the end, we also sent emails to each of those companies to ask for confirmation or information, which we have to do as journalists, as right to reply kind of obligation. Then the major, one of the major findings, sorry, I'm very tired. We were online at 6 this morning. It's the collection of sampling data that we've made across Europe. Again, it's imperfect. There is much more data, but we couldn't collect everything. So, but you can access all the data sets on Le Monde's website. And what we found are more than 17,000 known contamination sites across Europe, which are sites where PFAS was detected at levels above 10 nanograms per liter. And we chose that threshold for the simple reason that a lot of sampling had 10 nanograms per liter as a detection level. So this is why we didn't take what was underneath, but the data is still there for whoever wants to see it. Then when we finally managed to gather the data, and it was still coming yesterday, we tried to calculate how many hotspots, and that's something we can surely discuss afterwards. How to define a hotspot, I think, is a major and super interesting question in terms of science. And the number of hotspots was so high that we calculated clusters instead, because whenever there is a contaminated place that is detected, like for example, the two facilities of DuPont and 3M in the Netherlands and Belgium, lots of sampling is being done by the authorities. And so we cannot consider every sampling point with very high level around the facilities as hotspots. So we calculated clusters, and the total number we reached was 2,100 hotspots. Then that's a category that was not in the American methodology that we created with their agreement of PFAS known users. These are facilities that are using PFAS to manufacture their own products, but they are not synthesizing the PFAS themselves. And so it's like a middle level of evidence between known and presumptive. And we thought most of them were found by chance, and we thought it's a shame to lose the track of those spaces. So we created this specific category. Most of them are plastic producers. And then what I think is the most interesting things in terms of action, public action, is the presumptive contamination sites. So we reached a very high level of 21,000. So this definition is sites presumed to be contaminated on the basis of scientific investigations and expert advice without sampling data. And the basis is that those spaces were documented by reliable sources as PFAS users, but also as PFAS emitters. So it's a double criteria that helped define those spaces. The way the Americans did it was not possible. It was not possible to do it the same way in Europe, for the simple reason that we don't have geolocation of economic and industrial activities in Europe, which was a surprise for us. So what we did, there are more details in the methodology, is that we cross-matched the industrial activities that the Americans have identified by their NAICS codes, that's the economic nomenclature, with the European NAICS codes. And with that, we were still without geolocation. We cross-matched this data with the European pollutant register data, which doesn't have all these activities, but has very refined descriptions of industrial activities that we could match with those codes. Then the result is that we found, sorry, it's in French, the majority of presumptive contamination sites are linked to the use of firefighting foams, which is not a surprise, I guess, for people who work on this topic. We have this waste treatment and wastewater treatment sites that we gathered in the same category. Then we have industrial sites, and for which you have the details on the table on the left. Airports, there are more airports than counted initially in other reports. And then the military sites, I think, is something significant that we are bringing as information, because there is no database of military sites these days, especially with the war in Ukraine, and we had to do it by hand, one country after the other. And we located 642 military sites, which are, we know, major users of firefighting foams, of AFFF with PFAS. Well, all the details and figures can be found on the Monde website. This is, I'm sorry, I'm very tired, so I hope my English was not too awful. We are publishing in 17 outlets, so you have all your languages available. Some today, some later this week, and some in the next week. The reason is that we had programmed our publication with the beginning of the public consultation at ECHA, which is beginning on the universal restriction. And our idea was to bring enough information to the public for them to participate to this important public debate. Thank you, and I'm open to questions.
Yeah, thank you very much, Stephanie. That's really super work. And you know, we have here scientists and we have here people which are doing remediation of sites. So this means you gave homework for the next decades to us. Are there questions to Stephanie from audience? Yes. I have also a first question, Stephanie. Now there are these 20,000 sites where you do not have data. So if now science could bring in more data, can this be somehow added to your system, or how you think might your system further develop?
Well, the thing is, that's one of the limitations of journalism, is that I would like to work on PFAS full time, but I can't in the next years. So we have, there's a page in English on the Mond's website where you have the map, all the figures, the explanations, but also you can download the methodology and the 2 data sets. The map data set that is with the data behind the map, but also what we call the expert data set with all values below 10 nanograms per liter, for example, and many details that we had to simplify because we couldn't display. It was already a big challenge technically to do this map and to have as much information on it. And so what we have in mind now is that we can make corrections until the 1st of March, but then it's up to the scientific community to take this data, improve it, correct it, and use it for the public.
Question? Yeah. Hello.
Roland, may I have a question?
Wait a moment, Xenia, we have one from the audience and then you.
Yes.
From audience.
Thank you. Yeah, I'm just a little bit curious to know if you have been able to do some research on the type of firefighting foams used during the war in Ukraine. If somehow we can estimate the magnitude of the problem there related to PFAS.
I had never thought of that. It's a very, very, very relevant question indeed. We can assume that there's a lot of contamination due to firefighting foams in Ukraine now. That's for sure. But of course, I mean, there's no way to have, well, sampling data. That's for sure. But I think that would be a good public research question to map places where the foams were used, are used during the war.
Yes, thanks, Xenia.
Yes, thank you. And thank you, Stefan, and thank you for this great work. And it's very welcome, I think, having an overview of possibly contaminated sites is really what is needed to first prioritize where to look. And so it was very helpful for environmental chemists. I also had a question a little bit similar to what Roland had, was the update of the maps, because we saw that about 16,000 potentially contaminated sites in Denmark have not been included. Maybe this came after, but it would be relevant to include them, I think. And then I think also for the Aragon project, if granted, we would be looking into like if we could take on these maps and for the GIS maps that I mentioned earlier. So I hope that we can actually make use of it in a stable format where people can continue to access it. And then the last thing is a question. When you show the concentrations at a site, is that a single measurement or could it be multiple measurements?
Just to answer to address the Danish data issue, is we collected data from Denmark, and then we reached out, like for lots of countries, we reached out to colleagues in each of the country where we had a lot of data for them to create their own coverage and collect their own information and bring it back to us to improve the data. And this work is still, it's been super intensive, and so it's unfinished. I mean, I've heard that the data I have is not the most updated one, but I didn't have the means to collect the newest because I was busy, counting hotspots in France. So this is also we have lots of limits in our work, and we have no problem acknowledging it. I mean, even yesterday we identified a major problem in one of the data sets, the Rhine aquifer data set. Something went wrong, and we had we had to lower the number of hotspots by 200, which is huge. So there must be lots of mistakes here, despite the fact that I had the opportunity to work with my data colleagues at Le Monde, who are really very good at what they're doing. And then to answer your question about concentrations, we couldn't display values for all PFAS that were tested because sometimes 30 different types of PFAS are tested, and the tooltip, which is the box that appears when you hover on the map, couldn't contain as many PFAS. So we chose to give the data for 6 PFAS that we've selected according to the priorities of the HBM4EU program. And so the values we give are for those PFAS when there is data for those PFAS, and the sum of total PFAS, so the total concentration. And in the expert data set that I mentioned earlier, all this data is available. So this explains why, for example, if you look at the tooltip on the Arkema and Daikin facilities in France, which is the major #1 hotspot in the country, the numbers are very low for Arkema. It's because they are emitting 6.2 FTS, and 6.2 FTS is not in the PFAS we display. So the total concentration is very high, but you have almost nothing else in the tooltip, and this is because we just had to make a choice in terms of displaying information.
Okay, thank you very much. And I hope also that this will point towards the need to be able to register such facilities, both those that are producing and manufacturing, not just for PFAS, but I think in general, because it shows that we really lack this information when going out looking for pollutants. Thank you very much.
Yeah, Stephanie. And we have a question here from the online audience. So the question is from Julie Kofod. It is obvious that the data from each country is very diverse. How do you handle this in your communication to the public? I mean, also, for example, when you look to Wallonie and Flanders. Stephanie?
Yes, well, that's of course a very difficult question. We explain on Le Monde's website. We explain what to the readers that what they're seeing we're trying to explain what they are seeing, including this issue of hotspots, or the reason in the print edition of Le Monde we explain why Flanders is so red, for example, and it's because there has been a lot of sampling there. There's also a disclaimer that we co-wrote with our peer reviewers, explaining that it's not because there's a lot of data somewhere that it means that the place is more contaminated. It just means there is more data. Well, all these limitations that you can have when you build a map with non-comprehensive data. And so I guess it would be even for non-journalists, the issue would be the same. I guess what is behind your question, Julie, is how not to make the public panic, and somehow it's almost like Greta Thunberg said, "I want you to panic," in the sense that PFAS is a very, very serious issue that we have, and one of the major questions that came to my reflection in the past month is, why is it not in the public radar all over Europe, and why has it been in the US for 15 years? And so I don't want, the idea is of course not to scare the public. We were very meticulous and very prudent and conservative in our estimations, but I think that if the opinion can be shaken and awareness can start on PFAS, then there will be a real discussion at the EU level during this restriction discussion.
Okay, thank you, Stefan, from the Journalist Consortium. Now we'll go to the last speaker of today on this session, and that is Mr. Sergejus Ustinov from the United Nations Food and Agricultural Organization in Rome. And he will present per- and polyfluoralkyl substances, PFAS, and the global dimension of soil pollution. Good afternoon. I think the floor is yours.
Yes, good afternoon. I hope you can hear me well.
Yes.
Okay, perfect. Well, ladies and gentlemen, good afternoon to everyone. It's my pleasure to talk about PFAS. And once again, I would like to congratulate the Journalist Consortium from the previous presentation. It was absolutely a fantastic job. Well done. And it's also my honor to be the last one, and yet one more time to emphasize the importance of PFAS in the context of global soil pollution. My name is Sergejus Ustinov. I'm working as a soil pollution consultant at FAO, at the Global Soil Partnership Secretariat, abbreviated as GSP. I'm also the coordinator of the International Network on Soil Pollution, abbreviated as INSOP, as you can see here, where I'm going to have a chance to present you the network scope and objectives. And the title of my presentation is PFAS and the Global Dimension of Soil in Soil Pollution. This presentation has been done together in collaboration with Professor Ravi Naidu from University of Newcastle in Australia, who is also acting as an INSOP chair. And yes, so one more time again, I think we all heard a lot of interesting information over today's session and in the past 3 days about PFAS, the forever chemicals. The chemicals, why is it forever? Well, because they do not break down or do so very slowly under natural conditions. Given its stability and persistency, it's also known as forever chemicals. And in fact, they are very persistent and tend to accumulate or concentrate in the environmental compartments like water, air, sediment, soil, and even plants. Different sources say that we have about 8,000 or even 9,000 of PFAS chemical families, which are quite persistent. They have been used and are still used in many different applications. Name of the few are firefighting foams, paper, cardboard, food packaging, non-stick cookware, textiles, cosmetics, and electronics. We can continue the list on and on, but this is just the common ones that we thought to mention. The previous speakers and colleagues mentioned many different concerns related to PFAS to the human health and the environment. In fact, today, just to be brief stats, more than 5,000 PFAS spread a widespread pollution and exposure, threatening the soil health and food security. One of the problems, of course, mentioned previously is that emission of PFAS into the environment occurs along the entire life cycle of the chemical, starting from the production phase, use phase, and waste phase. As I said, they degrade very slowly and sometimes even do not break down. Quite toxic, they consider us quite toxic, and many PFAS have a planetary boundary threat characteristics. What does it mean? Well, basically, we are dealing with 9 planetary boundaries where chemical pollution is one of them. It's basically a planetary boundary is something that can lead to impacts at a planetary scale that threaten the vital Earth system processes. And in fact, PFAS are classified and have the characteristics of planetary boundary. The threat to the environment and the Earth systems are vast. When it comes to dealing with PFAS, we're talking about high costs. They spread diseases, damage ecosystem services, and their remediation is quite cost effective. Therefore, prevention is strongly needed to prevent PFAS from occurring. Just to complement something that was mentioned previously by the journalist consortium, a couple of years ago, the Environmental Business Journal mentioned and estimated the total number of sites within the US where PFAS contamination occurs. The figure was about 42,500 sites just within the US. You can see the breakdown of sites here in the table. The journal itself is open for public to have a look at it. So it's quite worrying. The figures are quite worrying what we saw in the US. And when it comes to the global one, the number of PFAS contaminated sites, more than 100,000 globally contaminated sites. And I think what we saw just a couple of minutes ago, if we're going to consider the presumptive contamination sites, this number going to increase even more. That's no doubts. The challenges, well, there are numerous of challenges when we're dealing with PFAS. There are thousands of them, and it's very hard to establish and study their environmental fate and behavior for all of them. Analytical challenges. To work with PFAS, you need to have a sophisticated and highly cost equipment and equip your labs with them. Not only that, you also need to have a right expertise and people who can work with this analytical equipment. Again, toxicity is one of the concerns and challenges that we're dealing with. And finally, remediation technologies. Now, today, of course, we have some remediation techniques already available, activated carbon, biochar. There exist of them for sure. But as of today, no remediation technologies are yet available to fully mineralize PFAS itself. This slide shows the critical zone. Now, basically, what is the critical zone? It's defined as the region from top of the tree to the bottom of the soil and groundwater that, if polluted by some pollutants, will affect soil health and food security. And we've heard a lot that PFAS, in fact, affect different environmental compartments. And even when they go to the soil, they can leach downwards to the groundwater. And the groundwater is not static, as we know. With this groundwater, with the water flow, PFAS can eventually enter the food chain, possessing huge risks to human health and the environment. Therefore, protecting critical zones is something that we should always think about and protect for having our soils healthy and food be securely consumed. If we're familiar actually with the WHO report, they estimated about 13 to 14 million people are dying because of the exposure to chemical pollution. Most of the deaths are by air exposure, but also soil. Around 4 million people are dying every year because of the soil pollution and chemical exposure within the soil. Having this in mind, United Nations said that soil pollution is one of the major threats to human health and the environment. And therefore, Global Soil Partnership last year decided to launch the International Network on Soil Pollution, focusing on minimizing soil pollution and achieving the global goal of zero pollution. Its mission is to support and facilitate in joint efforts towards reducing the risks of soil pollution and effectively remediate already polluted areas. The network is targeting both diffuse and point source contamination and will focus on many different contaminants, including the emerging contaminants. Areas of work are vast. Currently, we're focusing on 6 main areas of work, as can be seen here in the pictogram, under each of which various tasks will be carried out to achieve the overall goal. As I said, we're still a young network, just less than a year of age. And what we've been doing over the last 10 months is creating an awareness relating to presence of contaminants, which is a crucial first step to start assessing different contaminants, mapping them, establishing monitoring and regulation techniques, promoting remediation strategy, focusing on nature-based remediation technologies, awareness raising on how unsustainable agricultural practices can lead to soil pollution and deteriorating food quality. And finally, we're also focusing on establishing the link to where soil pollution can lead to water pollution and vice versa, because these two components are very well interlinked with each other. We've already established our tasks for this year, such as short-term goals, as well as the medium and long-term goals. Just to name a few of them, I'm going to go in details to all of them. This year, the network will focus on publishing a technical manual on assessing, mapping, monitoring, and reporting polluted soils, which will act as navigation or a guideline tool to governments, stakeholders, technicians, and even farmers to understand much better how to carry out environmental risk assessment, how to prevent soil pollution, and how to mitigate soil pollution if you have already that in your fields. We're also going to collaborate with other networks at the GSP, where we're going to harmonize standard operating procedures, which will be completely for free to people all around the world to understand how to carry out analysis for contaminants of concern. Focusing today, this year, we're focusing on heavy metals, pesticides, and fertilizers. But also PFAS. PFAS is also on the agenda for our network. The first step is obviously to establish and strengthen the regulatory guidances and policies that yet to be fully established, because as we heard, we're still lacking this legal certainty that we need so much. We also would like to gather experts, including all of you within the network, which can help us to disseminate the knowledge, because there is a huge need for assemblage and dissemination of existing information on PFAS from developed countries to developing ones. We have a strong interest from African countries, Central Asia, Central America, and Southeast Asia, who wish to learn more about PFAS in the environment and their behavior. And so we feel that with your help, we can do that. Last year, for example, FAO, INSAP, and CRCK, which is under the leadership of Ravi Naidu, held a symposium on PFAS in Australia, where global inputs towards regulation, analysis, risk assessment, and remediation technologies been discussed with all scientists from all around the world. And so now we need to act. We definitely need to move from strategy to tactics. But in order to do so, obviously, the biggest issue is resources. What INSOP is currently doing, we're collaborating with governments, stakeholders, and private sector, because we need to bring all these parties together, raise awareness to them in order to get sufficient resources and support in order to carry out all the activities that have been mentioned in my slides and as well as in today's presentations. So, as I said, we cannot do it by ourselves. We need your help, we need your expertise and knowledge and will. And therefore, if you're still not part of Global Soil Partnership and INSOP member, we highly encourage you to join us by scanning the QR code here. You can see using your phone. In this respect, you will be sure, if you're going to put your email, you will be receiving constantly the emails on webinars, on upcoming activities, events that we're organizing within INSOP and at the Global Soil Partnership, because soil pollution is indeed one of the priorities for our organization. Other activities that including here, constant awareness raising on soil pollution, harmonization of standard operating procedures for contaminants of major concern, war pollution. Someone possessed a question about war pollution, and in fact, our division, INSOP itself, is focusing on war pollution. We would like to address this not only in Ukraine, well, Ukraine will be definitely the case study, but also in other regions where war pollution leads to soil deterioration and land degradation. We're going to investigate that later this year. Production of global soil pollution maps, sustainable remediation of polluted soils, and creating a global database of soil contaminant threshold values, something that we can do in the long-term goal. As I said, we're quite new member, new network with just 700 members from 90 countries. We're working hard to have the geographical distribution evenly distributed, and as well as to invite all types of organizations so that to be more representative around the world. Last but not least, I think it's time now. We heard over the last couple of days that soil pollution is really a global threat to all of us. And therefore, under the leadership of CRCK and Ravi Naidu, we think it's time to establish an intergovernmental panel on chemical pollution, the similar panel that we have for IPCC on climate change. The question is why we still don't have this for chemical pollution. I think we need to have one, and we're highly encourage you to scan again the QR code and sign the petition with which we can approach the United Nations with the asking for establishing this IPC panel on chemical pollution. All of your votes are counted, and therefore we strongly believe that only together we can combat the soil pollution and have our goals achieved as quickly as possible. I think this is my last slide. Thank you very much for your attention. If you have any questions, our team is more than happy to address your questions either now, or you can drop us an email. As you can see here, our contact details. Thank you very much. That's it for me.
Yes, Sergejus, thank you very much for the good presentation. I mean, actually, the process is already started, right, to develop the international panel on chemical and pollution. So there has been already 2 meetings, just 3-4 weeks ago, a meeting in Bangkok. So this is on the way, that process, and in some time there will be this international panel established. Are there questions from audience to Sergejus? One question from my side. Now we have seen we have a huge amount of data in Europe, for example, on PFAS, or America on PFAS pollution, but also many question marks on sites. So when I look to Africa or South America, so there are not many data. And when you talk about global soil pollution, I think in your first or second step, there was this monitoring part. So what practically are you planning to do, especially in developing countries, to get more data on pollution. For example, and we are in the PFAS session, yeah, then maybe we stick with the PFAS. Yeah, if there is any plan from FAO or in cooperation with other UN agencies.
Thank you for the question. It is a very important question that we're addressing. And the problem is that in developing countries like Africa, we have limited or no data at all. Specifically, we're talking about monitoring, right? What we're trying to do, the first step is, as I showed, in a couple of months, we're going to publish this technical guidelines where monitoring, how to monitor soil pollution will be explained in much more details. And what we would like to do is we're going to have a list of indicators, the most practical indicators that we have established in different countries where monitoring is practiced, including Lucas. Lucas is helping us. Lucas is the European organization, GRC, on soil monitoring. We're working with them, and we would like to explain to African countries and other countries, not only African, how to start monitoring your soil. Because as of today, we didn't find any information that we can use in these guidelines, in this tool that we're developing from African countries, for example. And so basically we're starting from the scratch when we're talking about monitoring. When we're talking about pollution and mapping soil pollution, there's a more progress here in individual countries. Not in all countries that we have, but some countries, they have data available. And so our team is gathering this information together in order to create a regional soil pollution map for the country where we have data. That's, but there's a lot of steps that needs to be undertaken in order to have the meaningful progress in all the countries.
Yeah, thanks much, Sergejus. Before Guido will give a short summary of our session, and then we will come to more question and answer. Here to the presenters, you could think about questions you want to ask other presenters. Yeah. So first now, for 1 or 2 minutes, Guido will make a summary. But if you think about it, if you have questions to other presenters, the presenters, please ask. And also to the audience, please think if for any of the presenters there you have questions. Yeah, we will have some more 10 minutes for question and answers.
Yes, thank you, Roland. It's been a very interesting day so far, and we're looking forward to the discussion. Of course, we kicked off at a typical 15 minutes late with Dr. Roland Weber and his personal experience and initial actions starting really in the early 2000s with PFAS. After Dr. Frauenstein gave a detailed presentation on the PFAS dissemination via water and soil, and he really highlighted the need for, how critical chemicals should be identified, and that there is really a lack of action at the front. Following that was Dr. Frank Thomas Lange, where he highlighted the complexity of monitoring PFAS in the groundwater at mega sites. From the Low Countries, Flanders to be more specific, Professor Schroeters and Mr. Ceenaeme presented the case in Flanders where, as many of us already know, there is a huge scandal surrounding the 3M PFAS production facility near Antwerp, which has significantly impacted the society in the area. After that, there was a short intermezzo from our PFAS, where the mayor of JAWORZNO presented some of the issues they keep facing with their HCH mega site in their municipality. After our coffee break, Dr. Xenia highlighted issues with the lack of reference standards and pointed out that there have been legal actions by some of the patent holders, and that really prevents a good detailed assessment. Dietmar Müller Grabherr from Common Forum then announced a call to rethink how we manage contaminated land. Following that was the journalist consortium of the Forever Pollution Project, represented by Ms. Stefan Horrell, which showed us the inventory they have done, and it was a very impressive data set that they have gathered, showing a huge number of contaminated or potentially contaminated areas in Europe. And we finalized today with Mr. Sergejus Ustinov of the FAO, where he highlighted some of the actions they are doing on the international front, and presented the INSOP and the IPC International Panel on Contaminants. Now, I give the microphone back to Roland to see if we can go to the discussion.
Yes. So is there anybody from the speakers who has a question to another speaker? Then she or he can raise his hand or directly speak and unmute the microphone. Xenia. So most has been clarified. So question from the audience? No? Then I have a question to all presenters. What would you see as the most pressing thing to do from your perspective to better control PFAS or address PFAS contaminated sites or your issues? Yeah, so open to answer to any of the presenter. If anybody want to reply on that question, what kind of, let's say, action he sees as a priority. Yeah, maybe I can add, I'm also one of the presenters, right? So, I mean, with Xenia's presentation, we saw that at the moment, we do not have these standards. Yeah, when you just look to PFOA, is one chemical which is now regulated in the Stockholm Convention. We have PFOA-related substances which are more than 150. And from these 150, we hardly do not have 10 or 15 standards. This means 140 of these precursors are missing, but we have a legislation in Europe with a limit, and with a limit of including these precursors. So I think that in addition what Xenia said, that we should require to the producers that they should provide the standards from the right of the beginning of the production. And at the same time, I think that would also prevent contaminated sites, and finally prevent that they have to pay hundreds of millions, which are doing now for PFAS. Yeah. So I think that if they give these standards for early warning from the scientists when they monitor, that this would also be good for the industry. So that's from my side now. Xenia?
Yes, thank you, Roland. I think we have a number of things we can do. First of all, getting the standards would really be helpful to take action within the current system. But I think another consideration is that given the number of sites that are potentially contaminated, there has to be some, let's say, political decision on how we start the cleanup, because we cannot clean up everything. And I think in considering that, it will also be an estimate of costs. And maybe there we can consider to use a combination of methods. So sometimes we can use the less certain group methods simply to get ahead, you know. And I think this is really important to find out where the most contaminated communities are. So this is dealing with the current situation of the current pollution. And then, of course, I think the PFAS restriction is hugely important to stop the pollution, because as long as we continue to pour them out in the environment, we will have problems. Thank you.
Thank you, Xenia. Then Stephanie.
Yes, thank you. Well, for me, as a journalist, but also as a citizen, there's this question of the polluters has to pay, and because the polluters have polluted for such a long time. And I think that the PFAS is a very key issue and example of how what are called negative externalities are completely threatening society as a whole, in the sense that we've heard there was this paper last summer about the
completely agree, Stephanie, with these payments from industry. And I think with our forum, the HCH forum, we see that for HCH. Yes, you're back.
Yes, I thought putting the remediation cost for Europe would be a good figure for the front page, but I stopped counting when I reached several hundred billions, and because I realized that this is beyond everything that has been calculated and that can be calculated. So I think what I mean to say is that there are needs for huge amounts of public money to research and control this pollution, and a huge amount of control on the companies who produce chemicals and who pollute the environment, and regulations that fight trade secret, which is always the argument for companies not to disclose what they're doing inside their boundaries. And I don't think that in 2023, with the gravity of the situation, companies should still be allowed to produce chemicals without informing the governments and the public.
Yeah, and I think, yes, we have to act quickly, because what we see with the HCH contaminated site here in Spain is that the public has to pay, the company is gone, the family is gone. Yeah, so now with the PFAS, we still have very active companies getting billions of dollars. And I think that in America, I have shown in my presentation that really something is moving. So I think we need to get something moving also in Europe. Also, we have a different legislation, but I think that's very important before also these companies are gone. Greet, please.
Yeah, yes, thank you. What I would like to say is that, yeah, sanitation remediation, of course, is very important, and I think many people will push for that. But meanwhile, so many residents are living on these sites. We know pregnant mothers are, for example, a very sensitive target population. So I think also we need to think about the people who live there for the moment in this generation, and give them also advice on how to deal with it and how they can reduce their personal risk. So I think this is also something we may not forget about it, to give tools to the people who live on these sites on how to best protect themselves.
Yeah, maybe Xenia, can you put this topic into your project on contaminated sites? Is this a part of your project? I mean, you know, to do a systematic communication of pollutants and how to deal with it for the people?
In the Aragon, we will work with some selected contaminated sites. We have a short list of 23 sites and across Europe, and we will provide some communication. But I think we will have to collaborate with others to actually reach out to all of Europe, because given the number of identified or presumably polluted sites that we saw from Stefan, it is a huge task, and there will be many more contaminated sites where people are living. And I totally agree with you, Greet, that we have to think of the people who are exposed to this. I mean, with thousands of sites, there will be many, many more sites where people are heavily exposed, and that should be a priority, I think, as well. But we will do our bit, but we will have to collaborate with others.
Yes, you're in touch with Greet? Yeah, maybe. Dietmar?
Thanks, Roland. I would name 3 action points. The very first is what Greet already referred, is come to action. The second is dialogue. And the third is allow authorities to develop for citizens. To explain, come to action, we had discussions on some sites which are investigated since a long time, that a lot of PFAS already left the site and you will never get them back. So it's important to come into action and to establish kind of lighthouse projects to learn together. The dialogue, well, already 30 years ago with easier to treat contaminants, we learned what society is ready to afford in times in terms of money. So we need dialogue of all stakeholders because we will not solve all the problems and there will be trade-offs. Third, allow authorities to develop, to deliver for citizens. There was a country very fit in contaminated land management 20 years ago, had a big or good team at the authority, at the agency, with 20 team members. Within 10 years, they lost or fired 80% of the contaminated land member teams. There are only 3 or 4 nowadays in place. That's not possible then to work on. So allow authorities and give them staff and money resources. Thanks.
Okay, yeah, thanks, Dietmar. And Sergejus?
Yeah, I just want to complement quickly what has been said. I mean, from our perspective, what FAO can do and will do definitely is that we're going to approach the EU Commission and authorities to emphasize yet for one more time the importance of firstly regulate this topic and legalize everything, because without proper regulations and legislations, we're going to deal with more and more sites every year all around the world, not just in Europe, and that's going to never ending story. So firstly, what we're going to do, we're going to approach the European Commission with policy recommendations that needs to be formulated. And then after that, we're going to start the process on remediating the hotspot sites that needs to be remediated at the first stage. Thank you.
Yeah. Thank you. Thanks to all presenters. Is there any question in the room still? If not, I think we can give a big applause to all presenters again. And also to the audience for long time listening. Yeah, and I wish you good afternoon. Now we have lunch, right?
Yes.
And in the evening is the resolution. Yeah, so thanks very much. And all the best for your work as authority or as remediator or as scientists, yeah, to support a more clean environment in future to save human health. Yeah, thank you very much.